our expert, Dr. Lini Matthew. She is Professor and Head Electrical Engineering Department at this National Institute for Technical Teachers Training and Research. And she has more than 30 years of experience in this field of teaching. And she is an expert in this artificial intelligence, fuzzy logic, and she has made like many PhD scholars are there under her working in this area. And I think her lecture will be really very useful for you and for all the researchers at various nodal centers and for all the teachers. And I just hand over the session to Dr. Lini Matthew.
Thank you, Shimi. Good morning to all of you. I will be starting with a fundamental lecture on neural networks, what neural networks is, and then we will go on to the neural network toolbox of MATLAB and how the coding, some symbol commands by which you can do coding using neural network toolbox. Okay. When we talk about neural networks, the word neural network comes from the word neuron, where neuron is the simple cell of human brain. Okay, so when we talk about a neuron or a neural network, we think about the idea which comes to our mind is the biological neural network or the human brain. So let's see what are the characteristics of a human brain. Ability to learn from experience, ability to generalize the knowledge it possesses, ability to perform abstraction or abstract knowledge. But the main disadvantage is it makes errors. As you all know, to err is human. Okay, so but all these other capabilities which we have listed out now, if we could simulate that into a computer, into a machine, or our main aim is to simulate the human brain into human brain and to have the capabilities of a human brain into a machine. Okay, so for that is our ultimate objective. And now we have various methods of simulating it. That area of knowledge or area of study we call as artificial neural network. Okay, so before we go into artificial neural network, I'll give you some fundamental knowledge about human brain and neurons. In human brain, it is understood, people could not count it as such. They say that there must be over 100 billion neurons, and all these neurons are interconnected to each other by means of connections which are called synapses. And these neurons are very different from the other animal cell of our body. They are responsible for our thought, emotion, cognition, etc. Okay, so that is the main main work of a neuron. I'll show you some simple pictures of neurons and brain. You must be seeing it. So this is a picture of a single neuron. It is the fundamental building block of a nervous system. And it is understood that it performs computational and communication functions. Okay, other than so many functions which it does, these two functions is that which we are going to concentrate to make artificial. It is not that the neurons do only these two functions, but these two functions of the neurons are that which we are going to emulate in an artificial neural network. You have seen a tail-like structure. It has so many tails and one nucleus or a cell body. It is a many inputs, one output unit. Okay, I'll show you more pictures of it. It consists of different tail-like structures, and these tails are known as dendrites. Dendrites are the tails which carry the input into the neuron, and axon carries the signal away. So when it is a many input and one output unit, we can understand that one neuron will have various dendrites and one axon. Okay, and it has a cell body and a nucleus. Each of these dendrites will be connected to the axon of another neuron by means of a connection which we call as a synapse. Synapse is what we call as a connection. Okay, let me not go into lots of details of this. There are more details. I am not going into those details. Let us come to some similarity of computers and human brain. Both operate on electrical signals. Yes, there are some electrical signals or some potential difference happening within our human body. You must be knowing that. That is the reason why we could measure the heartbeats or the signals from the brain by means of EEG and ECG and EMG, because there are small amount of electrical signals which travel through our body. So this is a good encouragement or good idea for the engineers. Okay, so it is both computer and human brain have electrical signals within it. Both are a composition of large number of simple elements, and both perform functions that are computational. They believe that the information which goes into a neuron are computed. The main computation which are done is multiplication and addition. That is what they believe. And then the signals are transmitted out of the neuron. Okay, so these perform functions that are computational. But what are the differences? Compared to the microseconds and nanoseconds time scales of digital computation, nerve impulses are very slow. Okay? Human brain is a very slow equipment when we compare with the computers or which we work on. The brain's huge computation rate is achieved by a tremendous number of parallel computational units. I told you there are over 100 billion neurons and around 100 trillion connections between these. That much connections we don't have in any proposed computer system. Okay. Another thing is, a digital computer is inherently error-free, whereas brain often produces best guesses, approximations, partially incomplete, incorrect inputs. Okay, so the brain usually work with partially incomplete or incorrect inputs. But you know, our brain has a capability of coming to right conclusions, even if the input is partially incomplete or partially wrong, whereas computers will not. If you give partially incomplete or incorrect input to the computer, you will surely get a wrong output. But our brain has a capability to come to right decisions and right conclusions, even if the inputs are incomplete. Okay, so many a time we have to simulate that capability also into the machine. Many a time we have to emulate that capability also into the computer system or machine. So when we design artificial neural networks, we have to go into all these capabilities of human brain. Okay, we'll go into more details. When we think of, again, some more comparison of a computer and a biological neural system. When we think of a processor, the processor of the modern computer is very complex, whereas biological neural system is very simple. The speed is very high for computers, but it is very slow for biological system. The processor, when we think of, there will be only one or two processor. आजकल फिर quad core भी आ गया है, तो maybe you can have 6 or 7, 8 cores processors, but in a human brain, each neuron is a processor. Each neuron is a processor. And similarly, memory, computing, reliability, expertise, operating environment, we could find that there are enough scope of simulating a human brain into a computer. So let us, when we go on learning this subject, we will be able to clear that how we can simulate these capabilities into a machine. So first let us think of a simple neuron. See, this is the simple picture of a neuron. Okay. See, it has many inputs and one output. That is what I told you. And the inputs I define as I1, I2, I3, In. And each of these inputs has a weight associated to it. Okay. And these input values and the weight values are multiplied and added. That's the first line I have written over there. I1 W1 plus I2 W2 plus I3 W3 till In Wn. You get a computed value X. Now this computed value is checked. What is this computed value? Is it having a particular, is it more than a particular value? I always tell a simple example to all my students. Is that when we are having a class here, we hear a sound outside, we don't know. Why? Because the computed output is very less. But if the sound is very high and we have more inputs along with it, कोई रोने का आवाज भी आया, कोई भागने की आवाज भी आ गया, so the inputs and the weights associated are more. The computed output will be more than a specific value. Okay, when the computed output is more than a specific value, we will all run from here. Okay, so that is what is meant by the word here, activation function. And I'm writing here a word called threshold function. And what is that threshold function? If X is greater than a threshold value, then S is okay, or S is 0. What is the meaning of it? If the sound is more than a threshold value, or if the computed value is more than a threshold value, we will all run from here. S is equal to 1, or else we all will sit 0. We won't do anything. So here, T is a constant value. So we can emulate that activity of the human neuron by simply giving an algorithm like this. We compute the calculated output by multiplying and adding I1 W1 plus I2 W2, and then applying a threshold function. What is that threshold function? If X is greater than T, S is equal to 1 or 0. So such function, every time it will not work like that. Our human brain does not work like that also. I will not do anything, or I will do. It is not a Boolean activity every time. No, we do something. Okay, it is not that we 0 and 1, our brain always works like 0 and 1. No. So there are various activation functions. Okay, it is not only that threshold, because this is a course on MATLAB. I will give you some MATLAB functions also in between. So now I am going to define some MATLAB functions for various types of activation functions. Okay, so this threshold function, which we usually call as threshold function, is not the name which MATLAB gives it. MATLAB gives it as hard limit transfer function. For all these activation functions, MATLAB gives the name transfer function. So the name is hard limit transfer function, or the function name is hard lim. X is the calculated value which we get, net output value, So what is the output? S is equal to 1 if x is greater than 0. S is equal to 0 if x is less than or equal to 0. Or the other function is the symmetric hard limit transfer function, or else we call it as a signum function or a sine function, where the output is not 0 and 1 but minus 1 and 1. If there is a positive value, we give a positive 1. If there is less than 0, we give a negative. So there are two activities now. It is not that you do something or you do not do something. You can do something or you can do something in the other direction also. So depending on the situation, we have that our brain takes various decisions. This is again another very common activation function we use because of its shape. Because of that S shape, people call it as S function, sigmoidal function, squashing function, logistic function. But the only thing is, it is not, the values are not 1 and 0. It has values between 1 and 0. ये नहीं आपने कुछ किया है नहीं किया है. It takes, the decision is that you have values from 0 to 1, 0.2, 0.3, 0.4, 0.5, 0.8. Okay. So that is defined by a mathematical function which is written over there as 1 by 1 plus e raised to minus ax. अभी तक तो हमें x पता है. X is, what is x? I1 W1 plus I2 W2 which we have done. What is this a? A is a multiplying factor which makes the function more linear or more sharp. Okay? If you want that your function or your decision making should be a slow moving, I should have more values between 0 and 1. Then I will take an a of low value. Here a is given as 1 by 3 for that blue line. And a is equal to 2 for the black line, which is a sharply moving line. You can do this by calculating. आप कोई x value calculate करके ले लो, कोई a value multiply करके s की value find out करो, 1 by 1 plus e raised to minus ax. When x is equal to 0, you will get s as 0.5. 1 by 1 plus 1 मिलेगा, 1 by 2 मिलेगा. For x values greater than 0, आपको क्या मिलेगा? Less than 1 by 2 नहीं, आपको 1 मिलेगा. E raised to x greater than 0 means you have some positive value. So e raised to minus x will be e raised to minus value. So that will be almost 0. So you will get 1. When you have a negative value, आपका e raised to minus x will be a positive value. For high values, it will be infinity. So 1 by infinity, you will get 0. तो आप a मल्टीप्लाई करने से आपका x की वैल्यू वेरी करेगा. a लोअर वैल्यू हो तो x विल बी लोअर. जितने आपका x स्मॉलर है उतना आपको 0 एंड 0.5 और 0.5 और 1 के बीच में 0.7, 1, 2 वैल्यूज मिलेगा. ओके, आप कैलकुलेट करके देख लेना, कैलकुलेटर को लेके ये वैल्यूज को लेके कैलकुलेट करके देख. ओके, देन वी हैव अनदर एक्टिवेशन फंक्शन, वी कॉल इट एज अ हाइपरबोलिक टेंजेंट फंक्शन. Here also what all I have explained is the same. You can have a tan h ax, हम इसको करता है, कितने ये है उतना आपके पास slow moving values होगा. The only difference between the previous one and this one is that this varies between minus 1 to 1 and the other varies between 0 to 1. All the other operations, a and multiplication and all will work here also. This transfer function in MATLAB is known as tan sigmoid transfer function, and the other one is known as log sigmoid transfer function, or we call it as log sig x or tan sig x. Okay. Then there are some linear transfer functions which varies linearly like this. We call it as pure lin. Then some post-lin positive linear function. It will have 0 in the range of x less than 0. Then there are two saturating linear transfer function which saturates at the value 1, and now in the other case it saturates at the value -1 also. Symmetric saturating function. Okay. This is again a very important function which we use very often and commonly in artificial neural networks. It is known as a radial basis function. You are all familiar with the Gaussian function or the normal distribution function. This is also a similar curve, and people believe that this is a very common transfer function which can be used for practical applications, practical engineering applications. So you may read in literature using these radial basis, RBFFN, radial basis feed forward network. Okay, when you read literature you will have such words. Don't get worried about it. Literature में ये सब भी है, इसका full form है. RBFFN means it uses radial basis function and it is a feed forward network. Okay, I'll explain what a network is and what a feed forward network is. Similarly, when this shape is a triangular, purely triangular, then we have a triangular basis function. When you open MATLAB neural network toolbox, you will see all these various transfer functions, training functions, learning functions, and we will go into the details of it also after some time. The first neuron model which I have just shown you is known as the McCulloch-Pitts neuron model because it is formulated by Warren McCulloch and Walter Pitts in 1943. He has defined all this, that it will have binary states, input neurons, activators, and the threshold functions. All these things they have defined in this, and it is known as a McCulloch-Pitts neuron model. But then after some time they could realize that all problems cannot be dealt with single neuron model and giving some inputs and getting one output. Okay, and all having only the every time the inputs and outputs are not binary. Okay, so this McCulloch-Pitts neuron model has been found out to be very obsolete and less capable. So there are more networks defined. So it has been found out that a single neuron model could not be simulated for all problems. So there are a network of similar neuron models. Now as you see here, you have a network of neurons. Here it is known as a single layer neural network where you have only inputs, the neurons and the outputs. The inputs are given to the neurons, weights are multiplied, okay, transfer function is applied, activation functions are applied, and you get the output. Okay, then in that also many a time it is found that you are not getting favorable results. So the next research is that we can have a multi-layer. There is an input layer, there is an output layer, and then there are hidden layers in between. So the input layer, the output of the input layer will be fed as the input to the hidden layer, and output of the hidden layers, one hidden layer to the other hidden layer to the other hidden layer to the other hidden layer. So last hidden layer, the outputs of the last hidden layer will be fed as the input to the output layer, and then we get the outputs. So we can have various layers of calculation, activation functions, and then you get the output. Okay, so that is again. So here there is a process. See here what is the main thing is we have a target output and some inputs and weights given to it. Now when you calculate, जो हमने अभी पीछे I1, W1, X activation function apply किया, you got and you get an output. That output is not the same as the target output. Then what will we do? We find out that there is a difference in value. So we change the weights accordingly by calculation, iteration. So changing of that weights with respect to the target outputs, target value which you require. So that process is known as training. So when there are different types of trainings, when you have a target, this target is there, इस target values achieve करना है मैंने, so weights को change कर. That training is known as a supervised training. But then researchers after so many years found out that all human activity is not target oriented. Many a time it is not that there is a big target and you have to achieve that. Many a time it can be like you refine yourself than the previous value. So the error between the previous iteration and the present iteration is found and the weight is changed. Okay, then again the new output is calculated. Then again find the error between the previous output and the present and see the error. So the error previous error से कम होना चाहिए इस iteration का error. Then again you do. So your ultimate aim is that the error between the output should be. Okay. So that type of a training is known as unsupervised. Okay. In some cases, it is not that it does not have a target at all. There is a target, but then the error is not calculated every time. It is that yes, there is a target. You are different from the target. There is a reinforcement. It is not that the weight is changed with the error calculated between the calculated output and the target. Such a training is known as reinforcement training. The training is only during the training it is said that you are on the right path. That's all. Or you are not on the right path. So that change has to be made. That type of a training is known as a reinforcement training. So now I have told you so many things. There are various training and learning algorithms throughout. It is not that neural network has come last year. Throughout these years, researchers had found out various learning algorithms. Supervised learning and unsupervised learning, I told you as it is. There is a single, in supervised, as you know, we calculate the value, multiply and then go it. Okay. In some cases, it is a gradient based. You find the error ka dE by dx and then do it. So there are two methods, least mean square and backpropagation. And in unsupervised, you have a competitive. It means one out of all the neurons, one will be a winner. And only the weight of that winner is allowed to change. So all the other weights are not changed. Okay. Then the Hebbian mein all the other weights are also changed. So there are different learning algorithms now in papers and research articles. You can read through and find out also. Okay. Now we'll go on to again some simple, because I'm going to make, I have told you several terminologies, learning, training, neural networks, multi-layer. Now we'll go on to a simple neuron network. We will take up a calculation, how to do the training, and then we will see how we can use MATLAB to do it. Okay. See, this is again McCulloch-Pitts neuron model. I told you is a very coarse type of an obsolete type of a model. But this model, perceptron model, is very commonly used. The word perceptron came from the word perception. Perception is to look into, to see, to watch. So here, this perceptron model is very good in classification. If you go to MATLAB demo, you will find a classification problem of bananas and oranges there for the illustration of perceptron. You can go into that. Similarly, you can classify, make various classifications. The main idea here is, I'll now explain the learning algorithm. The main idea here is that the inputs may be binary or may not be. It is not compulsory that you should have binary values or even bipolar values. But the output should be binary or bipolar. Okay, output should always be bipolar, because you are classifying it into two groups, 1 or 0 or 1 or minus 1. Okay, so here, after finding out the net value, which I was till now I was using x value, here I am taking the value net. The inputs are x1, x2, x3, weights are w1, w2, w3. So sigma xi wij you will get net, and applying net में threshold or hard limit हम apply कर रहे हैं. If net is greater than 0, y is 1, otherwise y is 0. अभी net is greater than 0, y is 1. What will happen? जो हमारा calculated output and target output में if there is a difference, then what we have to do? We have to make a weight change. Okay, how will we do it? So there is a weight adjustment. If the output is 1, but should have been 0, target 0, from a calculated output 1, then the weight will be changed like the present weight minus alpha xi. Or in the otherwise, if output is 0 and should have been 1, then it is w plus alpha x. It's a very simple exercise. Okay, we have very difficult learning rules also. There are also complicated learning rules, but now let us take the simple learning rule for you to understand. Take an example of an AND gate. This is the truth table, you all know it. And here let us consider two inputs x1 and x2 and the target t. Okay. So the first set of input is 0, 0. Let us take a random weight as 0.3 and 0.2. x1 के साथ 0.3 and x2 के साथ 0.2. So what will be the net for the first case? 0. Calculated output be 0. Y is 0 and t is 0. I am here. You can look into it. No weight change. Then next, 0 into 0.3 plus 1 into 0.2. The output is 0.2. Y is 1. T is 0. This is the first condition. If output is 1, should have been 0. So, this is the equation which we have seen in the last slide. What we will do? Alpha x12. So, first 0.3 minus, we take alpha is a learning rate. How fast we have to change the learning. You will see now, you can note down some portions of it and you means सारे कुछ आप note down नहीं करते, इसमें इतना कुछ difficulty नहीं है, you can understand it. Why I am going through this exercise is for you to understand what the training and learning process is. Okay, 0.3 minus 0.6 into 0, you get the weight as 0.3. 0.2 minus 0.6 into 1, you get the weight as minus 0.2. Now the new weights are 0.3 and minus 0.2. Okay, you can consider learning rate, any learning rate between 0 and 1. It is a homework for you. This same example you will do for different learning rates. 0.2 के लिए भी आप करो, 0.9 के लिए भी आप करो, फिर देखो whether it converges faster. Okay. Then third case, here the output is 0.3, so you get y as 1, t as 0. Again, change the weights. 0.3 minus 0.6, you get it as minus 0.3, and here you get it as minus 0.4. New weights are minus 0.3 and minus. Again, for the fourth values, you get y equal to 0 and t equal to 1. Y net आपको minus 0.7 मिलता है. ये ऊपर वाला weight हम जब हम apply करते हैं. Again we change. Here, you find that after this 4 iteration, you find that the weights are 0.3 and 0.2. Could you find any difference? आपने शुरू भी इसी वैल्यू से किया था. अब अगला iteration भी करो, same values आपको मिलेगा. So we call it as a non-convergent. न्यूरल नेटवर्क में ये एक बहुत बड़ा डिसएडवांटेज है. आपकी कैलकुलेशन विल नॉट कम एज यू डिजायर. इट विल नॉट कन्वर्ज एट ऑल. सेम कैलकुलेशन में आप घूमते रहोगे. ओके, सो देयर इज अ concept called add a bias. I'll explain more on bias, but now what we do is let us change that calculation net is equal to sigma x1 xi wi plus b. What is the meaning of the word bias, by the way? To be inclined towards something. आप भी बोलते हो ना, टीचर बहुत biased था, मुझे मार्क्स बहुत कम मिला. Yes, there is an inclination. There is a DC offset में हम bias बोलते हैं, DC offset. There is an increase of a level. So here also we do a bias, help by giving something extra. सबको grace marks दे दिया 10-10. Here also I am adding a bias of -1 to all the calculations. जो हमने पीछे आइट्रेशन किया, सेम थिंग आई एम रिपीटिंग अगेन हियर. अब देखो, फर्स्ट वैल्यूज द नेट बिकम्स -1. 0 था, अभी -1 बन गया. So y is equal to 0, t equal to 0. Okay, no calculation. Now here again -0.8, y is equal to 0, t is equal to 0. Good. How the value changes? Calculation weight change करने की जरूरत ही नहीं है. देखो, third also you get y equal to 0, t equal to 0. Only the fourth value में आके आपको थोड़ा problem हो गया है, उसमें भी y equal to 0 आ गया. So now you do a weight change, and we get the new weights as 0.9 and 0.8. And now when you do the calculation, you will find that all the y's and t's are same. This is the final weight. This is a simple example which you can do with pen and paper, so that you will understand what is the training process. Okay, you change the weights depending on the outputs you are given. Okay, now here there is a big problem occurring in perceptrons. Okay, I'll show you a picture here. See, in an ant, the first picture आप देखो, ant की values है 1 0 0 1 0 1 0 0 0 0 1 0 1 0 0 and 1 1 1. So now you have 4 points. You have to divide those 4 points into 2 groups, 0 group and 1 group. Now here, when I plot it on a xy coordinate like this, this is a 0 0 point, 0 1 point, 1 0 point, and this is a 1 1. These are zeros and this is 1. So you can define it, divide it by drawing a line. When you can classify the points by dividing the points into two by drawing a line, that is known as a linear separability. If I take this example of XOR, what is XOR? 0, 0 is 0, 1, 1 is 0, 1, 0 is 1 and 0, 1 is. Now try drawing a line to separate it. So this problem is not possible by linear separability. So perceptron models cannot be applied to a problem which cannot be separated linear separately. Okay, that is what I will show in the previous thing. Why is it so? See, we use an equation net equal to sigma xi wi plus. This equation this looks like an equation of a line. Y is equal to mx plus. Okay. So now the equation denoting this decision boundary can represent a line or a plane. On training, if the weights of training input vectors of correct response plus 1 lie on one side of the boundary and that of minus 1, 0 or 1, 1 or 0 lie on the other side of the boundary, then the problem is linearly separable. समझ में आ गया? Something like this. When you plot all your problems, and you can define it by drawing a line. Why was it not converging? Because the line which you make by the equation x1 w1 plus b is something like this. कहीं ऊपर को जा रहा है. It is not classifying the two set of points. But when I make a bias or any changes, when the line becomes like this, which classifies the two sets of points, then the system converges. Could you get the concept of linear separability? So, this is always a classification problem which have two sets of points. One is defined as a 0 output, other is defined as a 1 output, or maybe minus 1 and 1. The classification is always done into two groups, 1 and minus 1. Okay, is it clear? Now there is a little bit different network, Adeline network. In Adeline network, the output is not 0 and 1, it is 1 and minus 1, it is in bipolar. The inputs also could be binary, bipolar or real valued. So because the inputs are real valued, we make a little bit change in the weight adjustment. In the other case, because it was binary, even if we do like this, we will get like that. I'll tell you here. See here, t minus y. What is t minus y? Target and the y. Calculated output और target output का एक difference. Error. उसको हम अल्फा और इनपुट के साथ मल्टीप्लाई करके वेट के साथ ऐड करते हैं. बाइनरी होने में क्या हो जाते हैं? 0 and 1. 0 minus 1 you will get minus. So automatically this plus will become minus. Otherwise 1 minus 0, 1. So this becomes just like that. So that same only. When we are having real valued values or bipolar values, वो ऐसे प्लस जो पीछे हमने प्लस एंड माइनस किया वो नहीं चलेगा. I hope you have got it. तो इधर हमने एक माइनस और प्लस यूज किया. This is because t minus y and ये क्या आया? T minus y is c minus 1 or 1. But in this case, when it comes to Adeline network, because we have real valued or bipolar values, we have to give the value t minus y. Okay, it may be some real values between the calculated output y and t. Okay, so that is, this is, so here what we take is, take the actual error value and multiply with the learning rate and the input and then add it to the w value. So while we take the error, maybe we may get a negative error, so it becomes a negative, minus ho jayega. Positive error hai to add ho jayega. Okay, so I think now you have understood the concept of training. Now MATLAB has some learning functions. MATLAB has some learning functions and training functions. I'll go into then very simple, what I was doing only, it is the same thing only. Learn P is used as the perceptron weight bias learning function. Learn P, because perceptron के लिए हम learn P use करते हैं. Calculate the weight change for a given neuron from the neuron's input P and error E according to the perceptron learning rule. जो मैंने अभी तक बोला है उसी के डिपेंडेंट आप माइनस पी डैश और प्लस पी डैश कैलकुलेट करके उसके साथ हम ऐड करें E and P का मल्टीप्लिकेशन. दिस इज व्हाट वी हैव डन नो. एरर को लेके P के साथ मल्टीप्लाई. In normalized perceptron weight and bias learning function, the function is learn Pn. Okay, it can result in faster learning. That's what they say, and it calculates the weight change for a means you should understand what MATLAB does in each function. इसलिए मैं ये बता रही हूँ, because otherwise आप जो मैंने बताया same thing but little bit different way, least mean square वगैरह लेके MATLAB करता है. That's why I'm explaining this. Here what it does is, it has various input values P1, P2, P3 input values till PR. उसकी squares calculate करके 1 plus 1 is 0, 0 square. So it is square root of that. So we are calculating a mean square error. And then divide by P and get Pn. And that Pn is then used as the weight change. Okay, that is what we do in learn Pn. Okay. So each type of network, we have a different learning function and training function. Okay. Now I'll go to another type of a network. It is a multi-layer network. We call it as a back propagation. Back propagation is actually the learning rule. Error back propagation also it is called in some literature EBP करके literature में लिखा होगा, or it is written as EBP learning rule or back propagation learning rule. But it is, the network is not actually back propagation. The network is commonly a feed forward, multi-layer feed forward network. So it is known as an MLFFN also in some literature you will read, multi-layer feed forward network. So this is a multi-layer feed forward network. It has inputs I11, I1, I2 and I3, and there are two layers of weights. In the first layer the weights are VI1, VI2, Vij, and in the second layer the weights are Wij, and the outputs are O01. It has a step-by-step algorithm. Now I will explain this algorithm and I'll go to the back propagation, error back propagation and the gradient descent part of it. Little bit means I require your attention step by step carefully. जितना हमने perceptron में आसानी से multiply करके add किया, that is not the case here. Here it is a little bit difficult. So that is the reason why we require MATLAB calculations, MATLAB toolbox. It is not that easy that we calculate. See, our students of master's degree, I give this course as a 6 months course, which I am now telling in 1.5 hours. Okay. So here Each of these neural network, I'll make them do in the class. So it is a really tedious calculation. So you may ask me, ma'am, why should you do it in the class? You could have given MATLAB toolbox. Okay, you could have given MATLAB toolbox. Now all of you are using calculators. But did your teacher in second and third standard left you not studying the multiplication tables? करवाया है और 10th तक आपको कैलकुलेटर यूज करने में मना भी कर लो. Why? That basic understanding has to do. So that is why for the basic understanding, I request all of you who are in the different nodal centers also, do what I have told you in this class by actual calculating it in your notebook, so that your insight will grow. You will understand what it is. Without that clear understanding, neural network को use करना little bit आपको समझ में नहीं आएगा क्या हो रहा है. That is why I am making you do it. Okay, MATLAB will do so many things for you. We don't have to do like a workhorse calculating the values. We can use our intelligence in something else. So MATLAB is there to help us. But you should know what MATLAB is. Many a time I have seen students or researchers who use MATLAB and do not know what MATLAB is doing, and believing what MATLAB has given you. Okay, oh madam, MATLAB से आया output, वो तो ठीक है. How? It is not that MATLAB is a magician who can give you all right answers. You are making it do. You are the magician. You have to ask MATLAB to do the right way. So you should understand what it is. So this is my humble request to all of you, to understand what MATLAB is doing. Okay, each point what it is. इसलिए मैंने वो learn PN वगैरह मैंने इसलिए आपको समझाया. You should understand what it is, and it is there in MATLAB documentation. You can go into it and understand. Okay, now let us go for the one by one, step by step algorithm. In the input layer computation, the input value is taken as the same as the output of the input. See here, what is this input neurons? These are the input neurons, and you get the input and you take it as the output. OI is equal to II. That's first. And to get the input to the hidden layer, IH, you multiply this OI with the weight matrix V. OI multiplied by V. We get the hidden input to the hidden layer. Now at the hidden layer, we apply the log sigmoidal transform. 1 by 1 plus e raised to minus IH. There is a lambda over there which I was telling you about A. There is an FH over there to normalize or get the values within your limits. So all these you can do. Otherwise you put FH as 0 and lambda as 1. You will take IH symbol. So OH is the output of the hidden layer. Now with OH, you multiply by weight matrix and get the input to the output. Okay, so weight matrix के साथ हमने OH को multiply किया है, we get the input to the output, and then again log sigmoidal transfer function, output of the output. So calculations have been done, you got the output value. Now what will we do with the output values? We compare it with the target values. So you have targets, compare with the targets, find the mean square error, TO minus OO square sigma mean, we get the error. Now what do we do with this error? In the previous case हमने क्या किया? Error को alpha और input के साथ multiply करके weight के साथ add किया. This is what we have done in perceptron. Here we are not doing it, because I told you there in the first instance itself there is a big problem of non-convergence. आपने देखा, and it will, if you simply do like that, you will have lots of non-convergence problems. So people say that all the errors which we are getting, if we plot it on a XY plot, having your error and weight values like this, the error values will lie on a hemisphere like this. Sometimes it will go low, sometimes it will go up, again it will go down, go up, various values on this hemisphere. It will not converge at all. What is the convergence point? Which is the desired point is this global minimum. To achieve that, a gradient rule has been found out. Del E by del V. E is the error, V is the weight, plus del E by del W. So this is known as that you are differentiating the error value with respect to your weight mass. Okay, del E by del V. When you do del E by del V and del E by del W, you will find that your E is not in terms of V to differentiate it up. Therefore, your E is in terms of OO. You cannot differentiate it in terms of W. So what we do? Del E by del OO. And OO is in terms of IO. So del OO by del IO. And IO is in terms of OH or W. So you can do del IO by del W. Okay. So what we do? Del E by del W is del E by del OO by del IO multiplied by del IO by del. Similarly, del E by del V is, E is not in terms of V. So we have to partially differentiate it and go on. That is why this is known as an error back propagation. The error is propagated back from this to these layers. Del E by del W करने के लिए पहले del E by del OO किया, del OO by del IO किया, del IO by del W किया. But here when it comes to del V, del E by del OO by del IO by del OH and del OH by del IH and del IH by del V. यही किया आप देखो. This process of bringing the error back to the layers where the weights are is known as the back propagation, and that is why it is known as error back propagation. And we get values calculated. Del E by del W and del E by del V आपको मिलता है. उस वैल्यू से ये लास्ट आप देखो W and V आपको एक एक iteration का find out. Okay, it is not an easy calculation. It takes lots of time. I am not going into the calculations. These calculations takes lots of hand exercises. So gradient descent, there are training functions in MATLAB, which are known as train GD and learn GD. What is the word GD? Is gradient descent. What is the meaning of the word descent? Descent means utarna, downwards. Gradient means हम एक step उतर रहा है. You all know that the thickness of the step is same. हम तो सोचते ही नहीं है टक 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 नीचे जाएगा. Why? Because the height of the steps are same. Imagine that steps, अब 20 steps उतर रहे हैं. Each step कभी छोटा कभी बड़ा कभी छोटा कभी बड़ा, आप गिर जाओगे. Gradient means वो thickness same नहीं है. कभी आपका उतरना कम होगा, कभी आपका उतरना ज्यादा होगा. ठीक है? That is what we do. इसके अंदर आपको descend करके करके last point में आना है. And it is known that you will not descend every time. Sometimes आपका ascend भी होता है. ऊपर भी चलेगी आपका del W का del W and del V का values और weight बढ़ भी गया. समझ में आ गया? So we call it, but in effect आपको एक descent करना है in a gradient form. So that is known as a gradient descent algorithm. So the MATLAB also had given it as with the word train GD. Okay, उसमें कुछ नहीं है. There is a learning rate, जैसे हमने acceleration learning वाले लिख दिया. Learning rate से D performance एक word है, error की value divided by dx. Same thing which we have done in this. तो simply उसकी differentiate किया, multiply किया, dx find out किया, add किया. That is simple train GD. When it comes to train GDM with a momentum value, what is the meaning of the word momentum? Mass is there, or something else also is there? There is a moving. What is your moving here? I have shown you a hemisphere. So there is a movement of this piche. So we can have a momentum coefficient multiplied by. So the equation now has a momentum coefficient value also. 1 minus mc d perf by dx into LR and the previous value of x. जो x की जो previous value है उसको फिर multiply कर रहे हैं. So there is a calculations. So that the training is faster. Okay. Then we have an adaptive learning train GDA. Adaptive learning. In adaptive learning, there is after each epoch means iteration, if performance decreases towards the goal, then the learning rate is increased. Okay, learning rate में एक increase करता है, adaptive learning करा है, समझ में आ गया? So that will improve the performance, faster performance. Another one is the train GDX. In that, momentum and adaptive learning rate, दोनों हम apply कर रहे हैं. So why I am explaining you? When you go to MATLAB toolbox, it will give you an option: train GD, train GDA, train GD. आप सोचेंगे मैडम इसमें से कौन सा select करना है? हमें तो समझ ही नहीं आ रहा है. So now you know which one will give you a faster output, because मैंने आपको explain किया हुआ है. There are 4. मैंने आपको 4 explain किया: train GD, train GDM, train GDA and train GDX. Okay, so उससे आपको पता चल जाएगा, it gives you a better or faster performance in each the case. Similarly, gradient descent has a learning function. Learning function is weight and bias learning function. Okay, इधर क्या हो रहा था? Weight and bias variables, with respect to the weight and bias variables, वो performance पे ये apply कर रहा था. Performance की value find out किया, perf करके, उसके ऊपर वो dx के साथ वो कर रहा था. Here there is a weight value को learning rate के साथ multiply करके एक dw value find out करते हैं learn g. ये दोनों weight भी change होता है, हो रहा है, x value भी. Now I am not going into these details. There are various other networks, because my time is going out. There are various other networks. I will only name them. This is known as a counter propagation network, where it is a combination of a supervised learning rule and the unsupervised learning. Okay, this is an feedback networks. We have feedback networks. They are known as Hopefield networks, and it is used for remembering things. These networks remember your outputs, what you have saved in it. Okay, that is why they are known as associative memories. It will associate with some input values and remember the output value. Okay, so एक बार आपने उसके लिए train किया है, so when you give an input, it will give you the output. Okay, it will remember and get you the output. इसमें एक और point है, your input is incorrect or incomplete. even then it will give you the correct associated output. Okay, that is associative memory. उसमें ये character recognition वगैरह वगैरह में बहुत ये use होता है. Then we have a self-organizing maths. Here it is the competitive network. Competitive. इसका winner take all. एक winner है, it will take all the gift. That is the point. उधर कोई consolation gift नहीं है, ठीक है? Winner को ही gift है, prize है. इसका एक example है clustering. I'm only giving you the names, okay? Because this is not a course on neural network. If it would have been a course on neural network, I would have got time to explain it. I'm going fast. In clustering technique, see, you have a allocation like this. इधर देखो आप, red squares है, green cubes means prisms है, and yellow balls. तो मुझे इसको जो साइड में जो फिगर है उसके जैसे उसको क्लस्टर करना. All yellow balls together, all green prisms together, and red cubes. What is the technology there? What is the algorithm? Technology algorithm. See, this yellow ball will find the distance to all the other cuboids or whatever it is there. Then it will find the distance between the yellow balls. जिसका distance बहुत ज़्यादा है, comparison. So imagine this yellow ball is the most far off. This will get an opportunity to move, change the distance. Imagine it has moved here. Now again the yellow ball will find the distance. Now this has got the opportunity. This will move. The same procedure is done. This green prism is also doing the same activity. This red cube is also doing the same activity. So what happens? One each will be moving every time. And the threshold is a particular distance. See, if we are considering this to be moved, all these red should be moved together, we consider this. And this should be the maximum distance. ये threshold distance के अंदर सारे move कर. So here there is no target. No target. Every time the most distant object is allowed to move. Okay. Here the learning rule is known as a competitive learning rule or winner take all. And this type of networks are known as self-organizing networks. It does not have a target to move. It is an unsupervised learning or a winner take all learning. Okay, any questions? Okay, now let me go to MATLAB. In MATLAB, to work with neural network toolbox, we have to type on this NN tool. NN tool. Okay. See, a neural network data manager comes up. See, now first I'll explain you how the GUI works. MATLAB has given various. तुम लोगों को ये दिन नहीं दिख रहा है क्या? You cannot see this? Okay. See here, it will open a network, neural network data manager. Okay. Now here we have facility of inputting the data. We have facility of inputting the target data. We can define the network. Okay. We can train it, then get values. Okay. Now let me put into new. There is a new here. New में click किया. Create network data का एक और window आया. Create network data. In that there is an option called data, And here I'm going to name it as data 1, input data. Okay. What was our input data in the AND network? 0, 0, 0, 1, 1, 0, 1. As I've told you in MATLAB, everything is in a matrix format. Here also we will give it like that. So I'm going to give this as 0, 0, 1, 1. Okay. So मैंने कैसे किया है? One column 0, 0, 0, 0, 1, 1, 0, 1, 1. Okay. इसको मैंने क्या किया? एक कॉलम को 0, 0, 1, 1 semicolon 0, 1, 0, 1. Those who could not see, that's why I'm saying एक स्क्वायर ब्रैकेट के अंदर मैंने इनपुट को डाल दिया. ओके 0, 0, 1, 1 and 0, 1, 0, 1. 2 rows को बनाया. 2 rows को बनाया है. That is our input now. I have clicked on the input, create. Okay. New input data 1 is created. Okay. Now I have to create the target. What is our target? 0, 0, 0, 1 is our target. Okay. Click on the target and create. ओके तो इधर आप पीछे की GUI में आप देखो इनपुट डाटा के उधर डाटा 1 है, टारगेट डाटा के उधर डाटा 2 है. ओके नाउ वी आर गोइंग टू क्रिएट द नेटवर्क. नेटवर्क की टैब में हमने क्लिक किया. ओके आई एम गोइंग टू मेक एन एंड नेटवर्क. तो मैंने एंड नाम दे दिया नेटवर्क एंड. ओके इनपुट डाटा में मैंने डाटा 1 को सेलेक्ट किया. टारगेट डाटा में मैंने टारगेट डाटा 2 को सेलेक्ट किया. नेटवर्क टाइप आई विल सेलेक्ट परसेप्ट्रॉन. परसेप्ट्रॉन. ओके परसेप्ट्रॉन में आई एम गेटिंग हार्ड लिम. हार्ड लिम इज द ट्रांसफर फंक्शन. हार्ड लिम ऐसे भी कर सकते हैं बिकॉज हमारा 0, 1 की वैल्यू है, सो हम हार्ड लिम यूज करेंगे. ओके लर्न पी और लर्न पी एन दोनों यूज कर सकते हैं. हम अभी लर्न पी में शुरू करते हैं. लर्न पी. लर्न पी एन इज दैट यू हैव पी स्क्वायर P1 वो आपने देख लिया है, स्क्वायर रूट ऑफ दैट पी स्क्वायर एरर. एंड आई एम गोइंग टू क्रिएट द नेटवर्क. व्हाट इज द नेटवर्क? नेटवर्क एंड network type is, I am again repeating it, those who could not see it properly. Network type is perceptron. Input data is data 1. Target data is data 2, which we have already made. Transfer function is hard limb and learning function is learn p. Okay, go to create. Okay, what is the window? New network called network and added to the network manager. Okay, okay. Now see here, network and is come. Now if you want to see the network, there's an option here, view. See, you can see the network. The network has 2 inputs. अब देखो इधर 2 लिखा हुआ इनपुट के इधर. वेट्स के साथ मल्टीप्लाई हो रहा है, बायस ऐड हो रहा है, हार्ड लिम ट्रांसफर फंक्शन है एंड आउट. ओके this is how MATLAB views the network. Okay. Now let us go to close. Close this create network. Click on this network manager, network here. Now you have got some outputs here. Okay. Double click on that network. Now you have got another network window. In that network you have an option view, you have an option train, you have an option simulate, adapt, all those. Re-initialize the weights. आपने कोई weight नहीं दिया इधर. It is automatically taking the weights. But you want to start with the weights you want to give. You can do the initialize weights. Okay. Go to train. Train. Now first procedure you have to do is to trained the network. Input should be data 1, target should be data 2. Take all this. आपका output इसमें आ जाएगा. Train, there is another tab called training parameters. In that you can change the number of epochs. इसे 1000 दिया हुआ है, आप उसको 100 करो because छोटा सा AND नेटवर्क के लिए 1000 epochs की जरूरत नहीं है. और टाइम गोल्ड मैक्स फेल, ठीक है, आप ट्रेनिंग इन्फो में आ जाओ. ट्रेन द नेटवर्क. Okay, now the network is trained. You are getting an output window. It shows that the network is trained. It took 5 iterations. Performance is very good. No error, 0 error. Okay. Now if you want to see the performance, it will show you a graph. It told you that it has taken 5 iterations. Each iteration, this is the 0th iteration, 1st iteration, 2nd iteration, 3rd iteration, 4th iteration. Because there is a 0th iteration, they call it as a 5 iteration. So 5 iteration में error values क्या था? 10 raised to minus 0.2, 10 raised to minus 0.3, कभी 10 raised to minus 0.6, then it came to this value. Very low error value. This is this performance graph name. Okay, close. Now, the training is stopped. Now I want to see whether the values, means whether it works like a AND network. Okay, मुझे अभी एक AND network जैसे काम कर रहा है कि नहीं कर रहा check. Let me come to, तो इधर साइड में ही रखो. Come to the network data manager. Let me create a new data 3. Here let me give some values. I'm giving some values 1, 1 and 1, 0, 1, 1. See, 0, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1. This is the input I have given. क्या आउटपुट आना था? 0, 0, 1, 1 हमें आउटपुट आना है ना. 3 zeros नहीं डाला मैंने. 0, 1 is 1, 1, 0 is the other one, 1, 1 and 1, 1. So output should be 0, 0, 1. So this I have taken as another input. Create. अभी आप देखो डाटा 3 में आपको डाटा 3 करके एक इनपुट. Okay, now close this. Go to network and again go to simulate. Now simulate में आप डाटा 3 ले. Now you are not giving any target. You are not giving any target. Your output will be in network 1 and output. देखा? Simulate network. नेटवर्क हैज बीन सिमुलेटेड. इधर आउटपुट में आपको एक नेटवर्क आउटपुट मिल गया है. इस पे आप क्लिक करो, आपको ओके. सो फर्स्ट थिंग इज दैट यू हैव ट्रेनिंग डाटा. यू रन द नेटवर्क, मेक द नेटवर्क, गिव द डाटा, इनपुट द टारगेट, ट्रेन इट. अभी ये सिंपल है. इट विल टेक ओनली 5 iterations. मे बी यू हैव रियल टाइम वैल्यूज. ये नहीं है 0, 0, 1, 1 डालो. रियल टाइम वैल्यूज डालो, 0.1, 0.2 डालो and you get values. Now you give some testing values which are not given to it. ट्रेनिंग किया है तो टेस्टिंग वैल्यूज में आपको आउटपुट वो व्हाट यू हैव ट्रेन्ड इट विल गिव. आप इसकी और का करके देखो, एक्सऑर करके देखो, इट विल नॉट ट्रेन. ओके. सिमिलरली आपको फीड फॉरवर्ड भी कर सकता है. यू हैव वैल्यूज, डाटा वैल्यूज आप दे दो. क्रिएट न्यू में जाओ, नेटवर्क में जाओ, गो फॉर ए फीड फॉरवर्ड back propagation network. Okay, I'll finish it. Feed forward back propagation network. Okay, so you give the input data in a feed. As you select the feed forward network, you will see that your training, GDM, GDA, GDX, all what I have explained is coming here. Similarly, learn GDM, learn GD, all will come. Okay, and you can have different layers, layer 1, layer 2. So it is a multi-layer. You can go for more layers. And in each layer, you can change the number of neurons and the transfer functions. Okay, so this as a GUI, you can use it. You can write coding also. वो coding भी एक parts था, but time has gone very fast. I have no time for they'll give you the coding, but this is enough. When you sometimes you can attend my course on neural network only, artificial neural network and fuzzy logic. In that I may explain it more clearly because I get more time there. It is a 1 week course on neural network only, so I may get more time to explain it here. Sorry. Any questions from any centers? I'm closing the lecture now. The next expert has come. Any questions from any centers? Please, you can ask if you have any questions, or else let me close. Okay, let me close it now. We can have more interaction time if you require anything. I am here only. I'm not going anywhere. You can ask me questions after.
Thank you, ma'am. So I think this would have been a very useful session for you. And anyway, ma'am is here for the fuzzy logic also. So tomorrow also she is there. So if you have any doubts in this, you can just practice and you can ask her. And now we will go for a short break for 15 minutes. I think, let's say at sharp 11:30. It's not even 15 minutes, 12 minutes, I think. So we will sharp come back at 11:30. Okay, or 11:35. We will reassemble at 11:35. Our expert has already come. So we'll have a small, like you just want to set a system. Once it is over, we'll start after the tea break. So now the participants here can go and have your tea. Okay. And thank you. We'll again meet all of you at 11:30.
Here we go again. Over and over it. Here we
एंजॉय करें A very good morning to one and all. So we are going on to the next lecture. It is implementation of MATLAB functions using embedded MATLAB function blocks, Simulink. And we have with us our expert, Dr. Vijay Nera. He is Director, University Placement and Counseling Cell. He is a chairperson of Department of Electronics and Communication Engineering and Applied Science. And he is professor and head there in the ECE department. Uh, in the BPS Mahila Vishwavidyalaya at Sonipat. So I welcome him again to this course on STZ on MATLAB and its hardware interface from 11 to 15. This whole week it is going on, and our expert, he is even the expert in the S function. So because everyone, we are afraid of this S function. Whenever we think of S function, we don't do it. Sir is there. Even the afternoon session, he'll be handling the S functions for us. And now I hand over the session because we are getting late also. So I'm just handing over the session. Thank you.
Very tough. I hope discussing implementation of MATLAB embedded MATLAB simulating. In fact, when we come to this Simulink user-defined library, our focus is on customized application. So the agenda for discussion is the steps for engineering problem solving methods, how we create these embedded MATLAB function blocks and its application in different blocks. So the first thing is one should be very clear with what are the steps for engineering problem solving. There are 5 steps. The first step is you have to define your problem clearly. Then you have to identify the input and output parameters for your problem. Then you have to obtain the analytical solution of your problem, that by hand. And the next is you have to obtain the MATLAB solution of that problem either by using this text programming environment that you can say using MATLAB script implementation or using graphical programming solution using Simulink. And the final step is you have to verify your result. Right? In fact, throughout this embedded MATLAB function blocks, we focus on these steps. You take any problem from any domain, you have to identify your problem, input parameters for your problem, output, then you have to look for that solution. And there is not only embedded MATLAB function blocks where you can find the solution of the problem. There are multiple ways where you can implement your problems to find the solution using this scientific computing. So before coming to this whole this embedded MATLAB function block, one should be very aware. How can we use these scientific computing tools for problem solving? One can use either a package as a textual and graphical programming environment. One can use open source or this commercial package like MATLAB. One can have an option to use programming language. And if you use a dedicated package, then you have a here we focus on general purpose scientific computing. Yes, for a presentation. we use this general purpose package MATLAB for this simulation. In fact, before going to there are a number of use of that package. You can use at various levels, either as a teaching tool or you can focus in solving engineering problems. You can use it in handling data in your lab. There are multiple ways a user can use this. Then the very important thing is how we assimilate or how we use this package when we use this package. In fact, in most of the universities, it is integrated horizontally and vertically. You started using it from the first semester or first year along with C programming, and then you use it vertically across all domain of your curriculum.
Hello, excuse me, your voice is not audible here. Can you please adjust your voice? Volume of your voice.
Hello? Hello?
Hello? Excuse me, it's not audible here.
Hello? Hello? What is your Anji sir, am I audible to you? देखिए आज तो कुछ माइक नंबर ही ओके सर थैंक यू सर हेलो एट याचन बारा हेलो 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 यस मैम नाउ आई एम ऑडिबल टू यू
Yes, yes, sir, it is audible now.
ओके
But after you have extend over here.
that's because of your internet issue
You can use this package horizontally and vertically across your curricula, and if you are from the domain of electronics and communication engineering, you can use across all subjects, starting from the basic science to even digital signal processing, communication signal and electronic devices, and circuit control system, circuit and system for minor and major project. This whole discussion starts from this slide onward, and the first thing is the M files in MATLAB. There are basically two types of M file in MATLAB. One is script file that consists of a sequence of MATLAB command, and the second is function file. There is a difference between script file and function file. The function file accepts input and output argument, and it returns output argument. both the files are stored with .m extension, so both are known as M file. And as far as the execution of these script and function file is concerned, then it is different. So the first thing is how we write a M file. The first thing is we open the MATLAB desktop environment, then we open the MATLAB editor window, enter the M script into the editor, save the M file script, and compile and run the MATLAB script. In fact, for this embedded MATLAB function block, we have to write this MATLAB function. So it is important to understand the structure of the function file. A function consists of a function definition line where it starts with a keyword function followed by output argument, which is within a square bracket, followed by this function name and the input variable, which is within parenthesis, not in square bracket that I have shown here. Then followed by this help line and function body, and finally it ends. So in case of a function, the first line is always function definition line, where you have to define, where you have to start with the function, output argument within a square bracket, then function name and the input argument within the parenthesis. And the next thing is, in order to execute a function file, firstly go to MATLAB command prompt and type the name of the function and the input and out. The input variable is applied to the function and then execute it. So this is an example how we write a M file script file, and simply you can type it in any text editor. You simply copy them in MATLAB editor window and then run it. This is the way you can write a script. This is an example of a symbolic script. You can use symbolic methods of MATLAB and you can write this symbolic script. In case of a symbolic script, you have to define your
Hello.
symbolic.
Sir, I am from BSS College, and still your voice is not coming properly.
Ma'am, the problem is at your end, because at other centers we have confirmed the audio is properly transferred.
Okay.
मैम आप ना आपके इंटरनेट में मैम मे बी फ्लक्चुएशन के कारण डिस्टॉर्टेड नॉइज आती है, इसको डेडिकेटेड रखिए.
सर, जो प्रीवियस सेशन था उसमें वॉइस वाज वेरी क्लियर, बट आपके सेशन में नहीं आ रही है.
दैट्स व्हाई मैम आई एम सेइंग कि जब फ्लक्चुएशन होती है तो डिस्टॉर्टेड वॉइस आती है.
ओके. हेलो. Hello. Can you please speak loudly? Because your voice is really not audible. For the participants.
मैम आई एम सेइंग आप अपने इंटरनेट की डेडिकेटेड रखिए और बाकी सभी जगह अगर आप इंटरनेट यूज कर रहे हो उसको बंद कर दीजिए, बिकॉज आपकी मे बी फ्लक्चुएशन हो रही है, इंटरनेट कम हो रहा है, बैंडविड्थ, तो डिस्टॉर्टेड आवाज आ रही है आपको.
सर, डिस्टॉर्टेड वॉइस नहीं आ रही है, वॉइस स्लो आ रही है. वही
लो आ रही है मैम, देन स्पीकर्स का लेवल अप कर दीजिए.
ठीक है सर.
This is an example of a MATLAB script where we want to plot the time domain response of first order system, and if you look at this script here, we define it three functions. One is for step signal, and then the other is for ramp, and the other is for execution, impulse execution. This is the, can we write this symbolic script where we use this symbolic toolbox where we declare the symbolic. If you look at this function file, this is the function file of the first script file. Here the difference is the first line is your function, followed by within our square bracket output argument v1, v2, v3, followed by the name of the function RC response and the input parameter RC A1, A1, A2. So this is a script which is converted into a function file. Here the input arguments are R, T, A, A1, A2, which is clearly stated, and the output is V1, which is time domain step expression out, the time domain response, ramp response, impulse response, and then we write the expression for time constant, and then we plot. So here we have clearly specified the input argument, and once you supply this input argument, you can execute. If I take a simple example how we execute this script, specify your input argument. R is suppose 2.5 to 10 raised to power 3. E is suppose 0.00. A is suppose 10. A1 is suppose 10 and 10. So apply this input argument and then this is the way to execute this function. If you look at your script, and I simply copy a script and I try to run. This is the how can we instead of writing this, save it, put save it, desktop, this. Zero point zero is to take 10. So the first thing is you have to understand the difference between a script and function file, because for writing embedded MATLAB function block, you have to write function file, not script. This is the first thing that you have to do. Then, in case of embedded MATLAB function block, we have to write the code into this embedded MATLAB function. The first thing is you have to understand the specs of the general Simulink model. A Simulink model always source is the signals are used to excite your system. A system is an interconnection of objects that you design, and the sync is a this right for now. But it's not going to. Yes, in case of Simulink, there are 16 libraries, and your focus is on your 15th library, that is user-defined function library. This user-defined function library. This is this 15th library in Simulink group of libraries, and it is used to create customized functionality. And in case of this user-defined function library, it contains function block, FCN block, apply a specified expression to its input, denoted as U. MATLAB FCN block applies a specified MATLAB function for expression to input. And we have a embedded MATLAB function block. Some of blocks of user-defined function library allow MATLAB programming, and other allow programming language in certain forms. If you look in case of user-defined library, we have a embedded MATLAB function block and S function block. S function blocks allow programming in MATLAB as well as in C, C++, ADA, Fortran. Whereas if you look at this embedded MATLAB function block, it allows only MATLAB language function file. So this block accepts multiple input signal and it produces multiple outputs. If you want to create a Simulink model using embedded MATLAB function block, what you have to do? Firstly, look on the steps of engineering problem solving method. Find your input and output parameters. Then open a Simulink model window. Just copy this embedded MATLAB function block. Double click on this embedded MATLAB function block. Embedded MATLAB editor window will appear, and in embedded MATLAB editor window, write a function file, and then you save it and then execute. So this is an example photocurrent for computing this photocurrent of a solar cell. And if you look at the mathematical equation governing this photocell, then the equation is this ISC plus KI into minus PR into S. This is a fundamental equation corresponding to this photocurrent of a solar cell. So what we do to create an embedded MATLAB function block for this, firstly we write a function file. So we write a function with name photocurrent, and the input argument to this function is short circuit current, this KI, this T, reference temperature, and solar irradiation. And the output of this function is your IPH. This is photocurrent. And in case of a single output, there is no need to enclose it within a square bracket. So when you write function, the first thing is define what is the purpose of this function. So this function is used to compute the photocurrent of a solar generator. Then find out what are the input argument for this function. The input argument for this function is ISC, KI, T, PR, and this solar irradiation. Then the output is photocurrent. Then open your embedded MATLAB editor window and paste this function there, and then run your model. So it will create a Simulink model that is shown here. I will take example. Just the first thing is I try to show a number of examples. Then the second thing is, if you want to create the compute the reverse saturation current of a solar cell using embedded MATLAB function block, then again the steps are the same. What we do? Firstly, we write a function file, and the name of the function is reverse saturation current. It takes input argument ISC, Q, VOC, NS, A, AT, and it compute RS. We firstly write a function file in the syntax of the MATLAB, in MATLAB language, then we copy this function file and we put it into embedded MATLAB function block. Or you have an option, you can go into embedded MATLAB function block and you can write there. It's up to you. This is the way how can we look into the solution of the problem using this embedded MATLAB function block. We want to compute the reverse saturation current of a solar cell using embedded MATLAB function block. So look on the 5 steps of engineering problem solving methodology. Firstly, describe the input and output for this problem. The input for this problem is short circuit current, electron charge, open circuit voltage, number of cell in series, Boltzmann constant, this ideality factor, operating temperature, and output variable of the function is ISC, reverse saturation current. So the second step is to define these input and output variable of the function. Then develop an example. Here you focus on the analytical solution of the problem that you can solve it with by hand. The next thing is develop a Simulink solution. What I told in the first slide is in the 4th point. You can obtain the solution of a problem either using text programming environment or you can obtain the solution of a problem using graphical programming environment. Here we are obtaining the graphical programming using Simulink, the solution of the same problem. So one can also use MATLAB text script implementation to solve the same problem. Here we can also use this text script implementation or we can test the result for a variety of data. In fact, not only this by using this Simulink, there are multiple ways where we can look on how can we find the solution of the problem. In 4th step where we go for the MATLAB script implementation. What I told you is you can use MATLAB text programming environment. Here you require the MATLAB script implementation. It requires the knowledge of programming. Then you can find out the solution of a program using graphical programming environment, model-based design. Here you require the knowledge of Simulink library and graphical programming solution. Then you can create the basic Simulink model that you can create mainly using blocks of source, sink, and commonly used block library, math operation library. You can create Simulink model using tags of Simulink routing library. The same solution you can create using from and go to tag blocks of signal routing library. You can model using physical component, Simscape library. You can find the solution. You can model using advanced component in sim electronics. And then you can find out the solution of the same problem using embedded MATLAB function block of user-defined function library. Here in case of embedded MATLAB function block library, you require the knowledge of writing MATLAB function. And you can find the customized solution of the same problem using S function blocks of user-defined library, where you have an option to use S function level 1 S function block, level 2 S function block, S function builder block, and you can use this level 2 implementation of this S function block using C or ADA. So I just try to take one example. So first thing is to create the Simulink model of photo current. What we do, we go in Simulink library and firstly we copy this embedded MATLAB function block. In case of this new version, it is MATLAB function block. In earlier version, it is embedded MATLAB function. So you copy this embedded MATLAB function block. Double click on embedded MATLAB function block. This is your embedded MATLAB editor window where you write a function file, and here uh, I just take one function file that I have already written. This is one function file. I simply copy it and paste it here, save it. Photocopy. Close it. So what you find, this is your embedded MATLAB function block. Here it is created with the number of inputs that we defined in the function and with one out. So what we do, then we give it, we define the input and output of the function. So we go to the source library, take a constant flow, and in library take a display. So now come on this, you look at this MATLAB function file. The input for short circuit current is 3.74. This 3.7. This is KI 0.17. 288, 328 in the step of 10, 288, 10. It is a vector. There is reference temperature 98 and now this is your complete embedded MATLAB. So go in your and your this is how to get it. So the basic thing in embedded MATLAB function block is writing a function file.
हेलो
ठीक है
सर फ्रॉम आरटी कोटा
तो ठीक
हेलो
And
हेलो
ठीक है क्लैरिटी है
हेलो हेलो फ्रॉम आरटी कोटा सर सर ये आपका जो प्रोजेक्ट है इसको थोड़ा फोकस कीजिए, थोड़ा सा कम ब्लड दिख रहा है ये। नहीं आपकी वॉइस भी नहीं आ रही है हमको ढंग से, और क्या आपका ये ब्लड दिख रहा है थोड़ा सा। ठीक है फोकस नहीं आ रहा साहब।
सर ये यहाँ से फोकस्ड है हमारा, ये ऑनलाइन ही आपके एंड पे ट्रांसमिट हो रहा है। ये जब रेजोल्यूशन कम होती है, जब इंटरनेट स्पीड कम होती है।
ठीक है सर।
अब अगले ने दे दिया जवाब।
जवाब
दूसरा आगे दवा निकल गई तुम्हारी
वो नीचे
So this is your first problem where we create the embedded MATLAB model for computation of photofront of solar cell. Now, if you focus on this problem, again, if you want to find out, we want to create the embedded MATLAB function flow, we proceed again in the same way. What we do, close it. Open a blank model window. Go in user defined function library, copy this MATLAB function block and take your input and output. For output we take a display, and for input we again take a source. Double click on this MATLAB function block. This is your embedded MATLAB window. Now look on the problem. This is the problem we want to compute the reverse saturation current of the solar cell. So I have already written the function file for the same. Copy this function file. Again. This is your function. The input argument to this function is ISC, NS, A, E, and sub name of the function, reverse saturation current, and the output is your reverse saturation current. This is called comment. Input to the function, ISC, Q, open circuit voltage, Boltzmann constant. Output variable is your reverse saturation current, and this is your function that we have defined in language of MATLAB. The syntax that we use. Close it. So, your what you have to do is short circuit current is 3.74. Electron charge is 1.6 into 10 to the power minus. Define 1 Now, save this one. You can avoid this configuration. Check this one. Automatic parameters, automatic solver parameter selection none. This is an example. You can take an example from digital electronics where you can verify the bit table of 3 input AND gate, OR gate, and XOR gate. Again, for the same, what you have to create. Open blank model window. Copy embed MATLAB function flow. Then copy your function or write a function, whatever you want to write in embedded MATLAB function flow. So simply take an example. More complex. That's something. Compute this module saturation current and the mathematical equation corresponding to this I have noted. Error. The first line is always a function definition line, which is always starts with keyword function, followed by output argument within scalar bracket and then function name and the input. So this is again an example. You look on this function. Firstly, what we are taking the reciprocal of. We want to compute 1 by t minus 1 by tr. So 1 by t is taken as y2, 1 by tr is y2, y3 is y2 minus y2. And then we compute this 1 by t minus 1 by exponential of q qz 1 by tr minus 1 by ta. Write this in. Okay. Again, in the similar way, you have to take the input. This from you can take either from commonly used block library or from the source library. Constant. Things like mobility of electron and hole of difference at which are Half adder, full adder, and half subtracted and full. So what we do, first we focus on its half adder, and what it needs two input, and full adder needs three input. So how many input we need to, if I want to realize both it simultaneously? 5 input, 2 for half adder and 3 for full adder. So, and how many output we get? For half adder we get 2 output, and for full adder we get, for full adder we get 3. 2. So 2 plus 2, there are 4 output, and how many input? 5 input. So suppose we write a function, and we started with function, and output is your x1, y1, x2, y, and function name is half full, and input is your input is x, 5 parameters. Suppose you a, b, c, d, e, 5 input. In order to compute these 8 outputs, I have to use loop 4. So in half adder I use it 4 times, and in full adder I use it 8 times. There are 8 inputs to compute the output first. So that is the. So what we do, the usage is to make it as a half adder and full adder, and the input is input. There are 5 inputs: A, B, C, D, E. All are logical input. Yes, you have to write a code. Yes, whatever you want to do with embedded MATLAB block, the first requirement is what you have to write is a function file. A function file. So if you want to realize it using 2 half adder, and then you want to create a full adder, so what you have to do, you have to write a half adder. whatever you have functionality, you have to implement for half an hour, and then you can proceed. No. Nesting is possible. You can connect one after in a cascade manner. That is, you can do. There are certain model, like in case of photo current, where we have a number of equations covered photo cell. So what we do, we create a embedded MATLAB function for one. Like that, I have taken an example. One is for photo current, reverse saturation current, module current. So they can be used in any manner wherever required. This is an example of a to compute the mobility of a electrical conductivity and resistivity of, and the input that is given is mobility of electron and hole, and density of electron and hole density. So what is the mathematical relation to compute the conductivity? N into E into mu I plus mu. So that function name is resistivity 1, input is ENI, this first input argument, second input argument. Input, there are 4 input and 1 output, and this is the mathematical function how we define it. Again, copy this function into your embedded MATLAB function flow, provide the input, and run your. This is one of the examples to compute the capacitance of a varactor diode. Simply you use the mathematical relation of computing the capacitance of a varactor diode, epsilon A by, and write a function for the same. Your function is name is varactor diode, input argument are is output is this, and again paste this embedded this function file into embedded MATLAB function. So these are 3 inputs and 1 is your output. Logical operator. Suppose you want to verify the truth table of your AND, OR, and XOR function. So what we do, there are 3 input. This is the name of function F1, F2, F3 are the output, and this is the name of the function. Inputs are X, Y, Z. These are the input which is written. Output is F1, F2, F3. We use a for loop for m equal to 1 to 8. F1 equal to X and Y and Z. F2 is X or Y or Z, and F3 is X or this is the firstly we write for X or for X and Y, Z, and this is X. What we do, we copy it and we provide this logical input. This is logical. By how we provide the binary input, this constant block is we write that syntax logical within parenthesis and within square bracket we provide your binary input. So this is first binary input 0 0 0 0 1 1 0. This is second binary input and third binary input. This is your output. Take example. So copy again embedded MATLAB function to MATLAB, and as we want to display source, but we have to copy your function file for the same, write it here. definition line and comment, audio, close. So define
कैमरा जक दे मैं इथों
one. Close this square bracket and parenthesis. Logical. Save. Truth table. So this is how can you create a embedded MATLAB function block for the same. Save it, close it. This is one more example. The band gap energy for gallium arsenide is equal to 1.45 Planck's constant at 62 into 10 raised to power minus 34. Speed of light is, this is 3 into 10 raised to power 8, not 3 in, 3 into 10 raised to power 8. Calculate the wavelength of emitted radiation of LED of gallium arsenide. Suppose we want to create embedded, we want to find the solution of this problem using this MATLAB function block. What we do, firstly we write a function for the same. This is the function, output is f, name of the function is lambda. We define input argument. There are 3 input to this function, 1 output, and simply write this expression, f equal to hc upon az. Then how we create, we copy your embedded MATLAB function block from user defined library. MATLAB function block. Use this sync block for display purpose. User defined input from this constant block. Double click on this your embedded MATLAB function block. Embedded MATLAB editor window will appear again. Write a function here or copy already existing function. This is an example of this function. Double paste here. Close your embedded MATLAB editor window. Embedded MATLAB block will be created with the same number of input and output that we have defined in function. Give the input. Output. Provide the first input. And easy is 1.45. So in case of all example, any kind of problem, you have to proceed in the same way. This is an example of a how to realize half adder, full adder, and half subtractor and full subtractor. Here, these are two inputs which are for half adder. Two inputs, and this is the combination of three input. This is expression for sum and carry that comes from half adder, and this is the output that comes from full adder, sum and carry, and borrow and difference and borrow from half subtractor and full subtractor. What you have to do is, firstly you have to look on the Boolean expression for sum and carry, difference and borrow. You have to write it in a function file using the syntax of MATLAB language. Then you have to copy this function file into a embedded MATLAB function block. You have to provide the required number of inputs and output, and then you have to run your Simulink model. This is an example how you create a BCD to XS3 code converter using this embedded MATLAB function block. Again, the steps are the same. Implement your M function file, copy the function file, and put it into an embedded MATLAB function block, run the node. The next thing is how we create a custom block library. A block library is a special Simulink model. What you do is whatever the model that we have created, we can put it into a block library. We can create our own customized block library. When a block is copied from a block library to a model window, a link is established from the library to your the model. A block in the block library is called a library block. A copy of library block in the model is called a reference block. The main block is that reside in your library that you have created is your library block, and that you copy it in your model is called reference block. Each reference block has its own data, but the functionality is defined by the library block. Yes, this is very important. Each reference block has its own data. You have to provide the, like if I create a embedded MATLAB function block for all the problem as a customized library, what I to do, I take these all embedded MATLAB function block into your new library and I put it there, then I provide a path. So these are the steps for creating a customized library. The first step is open a new library window by choosing File, New Library from any model window menu bar or the Simulink block library menu bar. The second step is copy the desired block to the new library. And the third step is save the desired block library. And the fourth step is you can add the directory in which the library is stored to the MATLAB path. So reference block can find only library blocks that are in the MATLAB path or in the current directory. Once a block library is created, customized block library, and if you want to change it or edit it, so once you create a customized block library, save it, it becomes locked. So once a block library has been saved and closed, it is locked and cannot be changed. If it is necessary to change the block library, either to add more block or to edit the block library must be unlocked. To unlock a block library, what we do? Choose Edit Unlock Library from the block library window menu bar. The library will be unlocked as long as it remains open. To relock a block library, choose the library and then reopen it. When a block in a library is changed, the change will be applied to each corresponding reference block when the model containing the reference block is open or run, or when file update diagram is selected from the model window menu bar. So I will take how we create customized library. This is an example where we have copied only three blocks. One is your saturation current, other is photocurrent, and other is reverse saturation current. This is a library that is created, and if you want to use this block, what you have to do again? I will take more. Yes. Corresponding to each problem, what I have carried out is I have created a customized library. I copied each block into this library, and if I want to create a new model, what I do? I use this. Suppose we want to use a simple block. We want to compute paste. This is an example to compute mean and standard deviation. Provide input and output to the block. Input through this constant block and display So this block is copied from the library. This. You can take any block from this library. This is an example of a saturation current using the same problem using S function builder block that I take an example of this, suppose Hall coefficient. Provide the input and output. So if you look at this function file and you want to omit it, suppose it will not omit. This is, if you want to make the change, you have to make in your, this is reference block in main library block. So to unlock it, what you have to do? Edit, unlock library. Then you can make change here. So you can use any block of this problem. So in summary, it can be said that MATLAB function block is an implementation of MATLAB text-based description of M function file. It requires knowledge of MATLAB script implementation to build corresponding embedded MATLAB function block Simulink model. The MATLAB script implementation is a text-based M file description of system under reference that can be written in any text editor. One can implement the MATLAB script and Simulink model as a computational project-based model that can contribute to improvement in learning. Well, you can take any example. You can write the same. You can use it as a pedagogical tool in any area of your choice. The MATLAB function block can only be used to express the static nonlinear function described as y equal to fu, not dynamical system. The system expressed by complicated differential and difference equation cannot be modeled in this way. As function modeling technique can be used to solve this problem, to model more complicated problem. So this is all. Any queries? You can refer this book on Stephen T. Caris for this. So any queries, please?
If any center has any question, they can ask. You can turn on your mic if you wish to. Thank you, sir. Thank you, sir, for this wonderful lecture. Uh, we will meet after lunch break at 2 o'clock.
इसमें से मेट्रो है मित्रपाल ये नहीं करा देखो मैं अपना
ये वाला
हैं
यही कॉपी किया
नहीं इसमें बहुत मैटर है जो इनके यूज मैं इनको
चेतन का फोन है नीचे। चेतन का क्या बोला? ये नीचे बुला रहा है। चलते हैं यार, जाके करोगे इंतजाम करोगे। नीचे बताइए क्या बोलेगा? स्पीच दो, किसी सेकंड में बुला देगा। तेरे को पता है अपना है ना, लिख के देगा स्पीच के अंदर। और ना तो बोला अरे यार बढ़िया नीचे प्लान दे तो है चल गया चल गया सुनने कैसा हो अच्छा लंच ब्रेक चल रहा है हां अच्छे
ये चीज नहीं होती है जल्दी से बोल के नहीं चलता सूरज जमीन पे रह चीज का सामान नहीं अरे बोल दिया ना उसने कुछ भी बच लिया उसने बोला बोला वो जो उस बोल तो क्या ठीक है उसने ना पूरा प्रोसेस करके लास्ट बोला यार अब कुछ नहीं हो सकता है बड़ा सही है वो बोला बंद करवाएंगे तो यार बंद तो चार्ज भी होगा इसमें तो 7 GB तो माल अच्छा नहीं है इसमें तो बोला यार अब इसको क्या करें सिस्टम ले आया
अरे इधर आओ यार इधर
नहीं
मेरी बात सुनो मैं क्या कह रहा हूँ इधर
आईपी मैंने ना आईपी मैंने ना
मैं किधर से चला रहा हूँ
सीधे मेरे साथ जा रहे हैं तो मैं इसलिए तो बेफिक्र हो गया कोई नहीं है कोई नहीं है ना तू पागल है कि क्या कर रहा है
मैं बोल रहा हूँ आईपी कॉन्फ़िगरेशन
आईपी कॉन्फ़िगर नहीं करनी फिर क्या करना है इस पे जा
इधर 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 ये नेटवर्क पे। हाँ ये रहा नेटवर्क, ये रहा, ये इसको खोल, राइट राइट क्लिक है, ओपन नेटवर्क। हाँ बाहर देख लीजिए, लोकल एरिया कनेक्शन, लोकल एरिया चुप रहे, डिटेल डिटेल प्रॉपर्टीज पे चुप रहे। ये इसको 192.168.1 है, क्या हो गया? रुक जा, इसको ऐसे रखना जल्दी कर, खींच लिए बस बस हटाओ, हटा दे they are both digits created कर दिया बस एंटर भाई ग्रीन हो गया नहीं बैंड कर तो ही है यार भाई। हां चैनल ब्लूटूथ ऑन करके हां भाई इस तरह को थोड़ा क्लोज हो गया, ये भी क्लोज है ये दो तीन तो आ रहा है, ये भी आ रहा है, ये सारी चीजें एक अंदर आ गया इसको भी तो पीछे गिरोगे कैमरा को फिजिकली अपने दूसरे ऑफिस में देखें अपना वो है I
इधर मार्क डांस देने को भी अब सुबह सीआरटी में पढ़ा इंटरव्यू how to attend interview how to attend interview golden rules 16 रूल है 16 रूल है सबसे पहले आई कांटेक्ट प्रॉपर ड्रेस आई want to मतलब फेस करना उसको और गेट से एंटर कैसे होना है टिकट लो करके उसमें पीटी दिखानी उसको सर हमारी सीआरटी में एक क्लास में एक कोई तो कर लीजिए बैक्स वाली मतलब कोई क्लास नहीं हो रही सर सर सीआरटी में एक दिन में एक क्लास चाहिए सुबह बुलाते हैं सीआरटी में सुबह बुलाते हैं और ना क्लास में बैठे रहते हैं 10 11 बजे तक फिर उनका ऑडियो में चल जाओ फिर ऑडियो में थोड़ी देर वो लेक्चर देते हैं उसके बाद पूरा क्लास नहीं सर हमारी हुई नहीं क्लास से फीडबैक लिया जाए ना एक प्रिंसिपल सर कैसे बोले प्रिंसिपल सर ऐसे बोलते तुम लोगों ने आके मैं इन्फॉर्म नहीं किया कर दो उस दिन टीपीओ सर को इन्फॉर्म करा था तो टीपीओ सर हमारे पास आके बोल सकते फैकल्टी नहीं है कोई सर लेक्चर है तो दूसरे के पास ले लो सर ऐसे बोले कि टाइम टेबल चेंज हो गया टीपीओ सर के पास ले लो टीपीओ सर ऐसे बोला कि क्या कहते हैं ना मैकेनिकल ट्रांसफर में आ जाता है तो कोई भी बार समझाया तो भी काम सेटल में करने के लिए दिया करो ना हमारे से काम हो जाता है हमारी फीस का 4 साल के लिए सर 4 साल वो ऑटो पेड वाला हमारा 4 साल से करने पड़ता है 4 ऑटो पेड ना ऑटो पेड वाला खाली कर एक बार सर एक तो इनको वहां पे लंच आपने
So we have come for the second session here in the afternoon session, and our expert is also ready, and we are just waiting for 5 minutes because some of our participants are also on the way. And I just request that all the other nodal centers also, you can just make your participants get seated. We'll be starting shortly. जो भी नोडल सेंटर्स हैं, एक छोटा सा अनाउंसमेंट, मैंने सब नोडल सेंटर्स के लिए जो पार्टिसिपेंट्स का लिस्ट किस फॉर्मेट में, एक एक्सेल शीट का फॉर्मेट भेजा है. तो किसी नोडल सेंटर को नहीं मिला है तो प्लीज मुझे एक टेस्ट मेल कर देना कि आपको वो नहीं मिला है. फर्स्ट मैंने लाइक स्टार्टिंग में ही भेजा है कि बजट कैसे बजट कितना हम अलोकेट करेंगे एंड द टाइम टेबल एंड उसकी like list of participants की format, all these things I've already sent you people. So in case किसी center को नहीं मिला है तो please contact me. Okay, once again I'll just forward it. Today also I'll do one thing, I'll forward to all the centers so that you can start making your list of participants. अभी तो participants तो final हो गया. So please make the list of participants and send it to me within 2 days. Okay, for all the nodal centers, please make the list of participants in the Excel format, which we have sent you. Already I have sent the Excel format. Please make it in that format and send it to us. So we'll start the lecture shortly. So आप लोगों ने आपकी जो आया था सर्टिफिकेट के लिए टीम चेक करने का भरवा दिया, भरवा लिया, बट अब सर्टिफिकेट का भी अब स्पेलिंग वाला चेक करो, वर्डिंग भी नहीं है.
बिकॉज़ सर वो वायर है ना पीछे कट जाएगी.
हाँ, मैटलैब डालना हो शुरू करना. ओके, उसका कंटेंट अभी डालना है तो
वो स्लाइड तो इसमें पड़ी है, ये वाला.
ओके ओके. तो अभी यू वांट टू पुट द कंटेंट.
हाँ, कंटेंट.
Loudly, because
Mm-hmm.
louder they want.
I can speak with.
So a very good afternoon to one and all. So we have gathered here for the second session, and now we will be seeing the MATLAB with S function, and we have Dr. Nehra sir here, and morning itself we have introduced him, so like we are going out of time also, so let us start with the lecture. Thank you, sir.
Thank you. So the topic of this presentation is on implementation of customized functionality using S function. I try to cover S functions, type of S functions, usage of S functions, and flags in level 1 MATLAB S function, input and output arguments, and how we execute different levels of S functions, and structure of S function and file, how to write S function, and example of S functions in model. As I told you in first lecture, that a MATLAB function block is used to design static nonlinear system where we have an expression y equal to fu. But if we have a more complex system, dynamic system, we want to design with more complicated differential and difference equation, we prefer S function. The programmed S function, in fact, S function is a customized Simulink block where we write the code in the S function or program a S function using MATLAB language, using C, C++, Ada or Fortran. So the programmed S functions behave in the same way as your already existing blocks available in Simulink library. S functions have their own programming structure. Now, this S function is basically a part of user-defined function block library. The first is S function blocks. It provides access to S function. The S function named as S function named parameter can be a level 1 M file or a level 1 or 2 CMAX file S function, or a level 1 M file S function. We use S function block. S function block is used to create level 1 M file S function. A level 2 M file S function is an M file that defines the properties and behavior of an instance of a level 2 M file S function block that reference the M file S function in a Simulink model. The level 2 M file S function block is available in user-defined function library. Level 2 M file S function block is again available in user-defined function library. It allows to use a level 2 M file S function in a model. If you want to create a level 1, use S function block. If you want to create a level 2 M file S function, use level 2 M file S function block. S function builder blocks create a CMAX file S function from specification and C source code that we provide. In fact, if you are having a little experience in C programming, it is more preferable to use this S function builder block. Yes, S function example block it contains the example of M file S function, C file S function, C++ S function, Ada S function, and Fortran S functions example. So this S function example block contains example of M file S function, C file S function, C++, Ada, and Fortran S functions example. S function provide a powerful mechanism for extending the capabilities of Simulink. A user can create own blocks. S functions are Simulink block that can be programmed by a user either as an M file or a MAX file. S functions are basically of two types, either M file S functions or a MAX file S function. It is a computer language description of a Simulink block written in MATLAB, C, C++, Ada, or Fortran. What I told you is you have to write a language code either in MATLAB, C, C++, Ada, or Fortran. It can accommodate continuous, discrete, and hybrid system. In fact, nearly all Simulink model can be described as S function. The blocks that are existing in our library can be understood as a S functions. It enables user to add on blocks in Simulink model. You can create your own customized blocks. S functions are compiled as max file using the max utility as per other max file. If you are using a C language, then you have to execute this using max utility available within MATLAB. Now, the types of S function. I told you there are two types of S function. Either it can be implemented using MATLAB scripting language or C, C++ and Fortran. If a S function is written in MATLAB programming environment using MATLAB function, it is called M-file S function. If S function is written in C, C++ programming environment, it is called CMax S function. S function written in C with the later two needs to be compiled first. If you write a S function with C or C++, you have to compile first in order to produce a shared library loaded by the Simulink engine, while a MATLAB S function will be interpreted and executed during simulation. This is to understand the types of level 1 and level 2. This is MATLAB S function. This is max S function. In case of MATLAB S function, we have level 1 S functions, level 2 S functions. In case of max S function, we have C max S function, C++ max S function, and Fortran S function level 1 and level 2. So basically there are two types, M-file S function and max S function. So both we have a level 1, level 2, C max S function, C max, C++ S function. Now the usage of S function. S function is most widely used to create custom Simulink blocks. It can be used for a variety of applications, such as to implement algorithm in S function, for incorporating existing C code into simulation, used to simulate complex dynamic system. Any complex system can be modeled using Simulink, used to communicate with external device in hardware in the loop application, for adding new general purpose block to Simulink, for describing a system as a mathematical set of equation, to build a general purpose block that user can use many times in a model, varying parameter with each instance of the block, using graphical animation. In summary, S functions enable to create custom Simulink block in a situation where user cannot model custom functionality using the existing Simulink block. It enables to utilize existing MATLAB C or C++ code that model custom functionality. So it is used to create custom Simulink block. Now, in order to understand this creation of S function block, you have to understand the structure of a Simulink block. And each block within a Simulink model consists of a vector of input U, a vector of states, and a vector of output Y. The state variable may consist of continuous state, discrete state, or a combination of both. Hybrid system, they are both states. The mathematical relationship between the input, discrete state, and states are given as, for output equation, this, continuous state equation, this, discrete state equation, this. In S functions written in MATLAB programming language, the MATLAB S function Simulink partition the states into two space, continuous state and discrete state. Simulink partition the state into two parts, the continuous states and discrete state. The first part of the state vector is occupied by the continuous state, and the discrete state occupy the second part. In case of a block with no state, X is an empty vector. But in other programming language written S function, max file S function, there are two separate state vector for continuous and discrete states. How S functions work? S function consists of a series of basic subfunctions. I think before coming to this, I will try to show. Yes, steps for writing S function. There are basically three steps for writing S function. The first step is setting of initial parameters, update of states, and the third step is output signal evaluation. S functions, level 1 S functions are implemented as MATLAB functions, where the structure of a MATLAB function is keyword function followed by output argument, for output argument, sys, x0, string, ts, with the function name or file name of the function, input argument txu flag p1 p2, and this p1 p2 are the additional parameter that we can supply to the S function block as a through the dialog box. Flag is basically a very important parameter that tell the Simulink to perform the task. What kinds of tasks Simulink have to perform? U represent a column vector of block input. X is a state column vector of corresponding S functions block. T is current simulation time. F is the name of the S function block. S function file name. So this flag is basically an input argument which takes integer value, and there are 6 integer value that it takes. Yes, it takes 6 integer value. The first is corresponding to flag value 0. The Simulink perform the task initialization, and the syntax of the MATLAB function that it call is this sys x naught string ts. This is here again MDL. Yes, MDL initialize size txu p1 p2. This is sub function which it call. Continuous state update, the flag value corresponding to the flag up is 1, continuous state update, and the syntax of the MATLAB sub function which it call is sys equal to MDL derivative. This sys is the output argument that it returns during each value, each times the flag is used. Corresponding to this initialization, it returns sys as a state vector, as a vector of 6 values. Continuous state, it returns single output argument corresponding to this derivative function. Discrete state update, it returns this MDL update function. Compute the output, this MDL output function. Calculation of next sample time, and termination of simulation. This is so there are 6 flag value. As I told you, there are 6 flag 0 corresponding to initialization, and the S function sub function it call is MDL initialize size. Corresponding to flag 1, the S function sub function is MDL derivative, and it is used for computation of update of states. And this corresponding to flag 2, it is your S function sub function is MDL update, and it is used corresponding to discrete states update. Corresponding to flag value 3, MDL output is your this the sub function called is MDL output, and it is used for computation of system output. So if you look at the structure of a, this is your basically the first line in your level 1 MATLAB function. It indicates your input argument as 4, sorry, input argument as txu flag p1 p2, and output argument as sys x naught string ts. So depending upon this flag value, it assigns the tasks to perform using switch case statement. This t represents the current value of simulation time, x is current value of S function state vector, u is current value of input vector, flag is basically an integer which indicates the task to be performed. P1, P2, these are optional parameters which a user supplied through your dialog box. These are 4 output arguments which are written by the function. This sys, it is a multi-purpose output argument. The definition of sys depends on the value of flag. I told you corresponding to each flag. If you look at each value of flag, yes, corresponding to each value of flag, corresponding to flag 0, this is your S output argument. Corresponding to flag sys, corresponding to this flag 2, this, and so if corresponding to each value of your flag, there is different output argument. And it returns these 3 input argument. X is your initial value of S function state vector. The number of initial value is equal to the number of continuous state or discrete states in the system. str is a placeholder output argument. and it is set as an empty matrix, and TS is your sample time. It is basically a combination of two things, sample time and offset pair. Offset pair is normally taken as 0. In case of your first sub function, your SYS argument returned is basically consist of this number of continuous state, number of discrete state. It is a vector which consists of number of continuous state, number of discrete state, number of output, number of input, then is set 0. F is your it indicates direct feed through, and G is number of sample time. So this is the value of argument SYS. Now if the flag is 1, then SYS is a column vector of derivative of standard variable. If flag is 3, then SYS is a column vector of output variable. X0 is initial state value at flag 0. This STR is reserved for future. TS is an array of 2-column matrix containing the sample time and offset. Offset is normally taken as 0. There are 6 types of requests that Simulink perform, each of which is designated by an integer number. Flag value is 0, 1, 2, 3, 4, 9. In MATLAB S function, flags are used for indicating the current simulation stage. S functions code call the appropriate function for each flag value. These are the sub functions which are called by this corresponding to each flag value. 0, 1, 2, 3, 4, 9. Corresponding S functions, flags, and stages of simulation that we proceed. Now, if you look on S function, it can be a system with no state, having only continuous state, and having only discrete state. In a S functions, 2 functions are mandatory. This MDL initialize size, it is called every time, and this computation of system output, it is called every time. If you have a system with no state, no continuous state, no discrete state. In case of a system with no state, flag 0 and 3 are used. Flag value 0 is for initialization, flag value 3 is for computing output. And flag 1, 2, 4, 9 are set as empty string. In case of a continuous system, what we do, flag 1 is used, which is used to update continuous state. So the flag used for continuous system is flag 0, 1, and 3. And for a discrete system, the flag used are 0, 2, and 3. This is the S function action corresponding to this flag 0, it initialize. Corresponding to 1, it update continuous state. Corresponding to it update discrete state. Corresponding to flag 3, it computes output. Corresponding to flag 4, it compute next sample time. And flag 9 is used to terminate simulation. Yes, if in case of this first flag value, if we look at MATLAB S function structure, it consists of a top level function which is defined by function definition line, and it contains a number of 6 sub functions, each of which is called corresponding to flag value. Within the first function, MDL initialize size, the first command that it uses is size, sim size, to extract a structure variable size. And in this, there are 6 important and essential templates that are used. Number of continuous state, num continuous state, number of continuous state of the block, number of discrete state, number of output, number of input, and this size dot direct feed through is used to set your direct feed through, and it is set to 1 if there is a direct feed through, otherwise it is set 0. Direct feed through means that block output is a function of input. A block for which the output is an algebraic function of input has direct feed through, or where the states are explicitly specified in a system. Number of sample times offset pair must be at least 1, even for purely continuous S function. Now we come to the templates, M-file function and demos. In case of level 1 M-file S function, there are 5 templates, and it is always recommended to follow the structure and the convention given in the templates. You start with the templates available with the thing. So in order to look at different kinds of template, there exist several template files separate for continuous time system named as csfunc.m, discrete time system dsfunc.m, that can be copied to work folder. If you want to work with a continuous system, start with the template this for a continuous system. If you want to work with a discrete system, start with the template this one. If you want to copy or edit any template, type edit rather than type S function template this. So it will open S function demo. So this is the demo for of S function for continuous system. Demo discrete. The first line, this is your first line, which is function definition line. The input arguments are, output arguments are this. This S function template is basically for discrete system. There are 6 values of flag. In case of discrete system, I told you flag 0 is used for initialization, that is later on. MDL update case 2 for output, and for update is for discrete state, and case 3 is for output. These S functions are called. The first command in this your initialize size is sim size. This command is used to create a structured variable size. Then values are assigned to this structure variable size. The essential and frequently used template 6, number of continuous state, number of discrete state, number of output, number of input, direct feed through, number of sample time. And then this sim size command is used to return the output to a as argument sys which Simulink use. The 3 output argument x naught, it is your initial condition, str and ts. This is a 2-column vector. This is set as 0 offset, and this is your sample time. This is. If you look at this, there is a direct feed through in this case. So states are explicitly specified here. In case of a discrete system, number of continuous states equal to the number of row in square matrix A. So that is the command we use, size A1, to tell number of number of discrete state in the system. This is used to give number of output. Number of output equal to number of row in matrix D, and the number of input is equal to number of column in matrix D. So this is the template of continuous system, discrete system, and the flags which are used here is 0, 2, and 3. Now look on this is the template of continuous system. Function definition line, switch flag, case 0 and case 3 is used. Case 3, case 1 is for calculation of computation of or update of discrete states. So these in discrete system, flag value is 0, 2, 3. Here it is 0, 1, 3. Again, when you look at this, this is corresponding to this matrix A, B. It is already declared in the template. A, B, C, D. So corresponding to this, again, this is your first command to create a structure variable. Number of continuous state we tell it. Number of discrete state 0. Number of output 2. Number of input 2. Direct feed through there exists. Sample time is 1. Sim size we return it to the SYS argument, and 0 initial condition, and this sample time is 0 for continuous system. So this is the function that we call for computation of state as x derivative equal to ax plus bu, y equal to cx plus du. This is for this is an example. This is already available template for multiplying a scalar by 2 times 2. Here there is no state, no continuous state, no discrete state. So the if you look at on this switch flag, and the flag value used is 0 and 3, and the rest of is set as empty string. The state which are not used is set as empty string. Then within your MDL initialize size subfunction, the first command that we use to create structure variable, we define essential and frequently used member of template, number of continuous state 0, number of discrete state, number of output -1 dynamically sized, number of input -1 dynamic, feed through you have to specify number of sample time 1, and then output SYS MD. So the task performed by the task performed during flag value 0 is initialization. This is the task that is performed. Here you have to specify the block sample time. You have to set the block sample time, number and size of input and output port, number of input and output port, direct feed through, 6 essential members of the template. Calculation of next sample hit corresponding to flag calculation of output in measure time step, update of discrete state, and this is the way how the S function simulation cycle works. Initially, in the beginning of the simulation, the flag value is set 0 automatically, and Simulink call the initialize function. After it, in the first simulation step, the output argument 3 is used to compute the output. Firstly 0, then 3, then 1 to continuous state or discrete. 1, 3, 1, 2. 3, 1, 2. Then in the next simulation step, the same process is repeated. You are getting my point? Firstly, your 0, then 3 in the first simulation step, and then 1, 2, and in the next simulation step, the same process is repeated. This is S function simulation cycle. Yeah, there are 3 things that you have to remember. When we call this initialize size function, here what we are doing, we are setting the initial parameters. Firstly, statement size equal to sim size x except default parameters template size, which is a structure array. Then 6 essential and frequently used members of templates are called. Number of continuous state, number of discrete state, number of output, number of input, direct feed through, number of sample time. After the members are set, the template size can be returned with the statement sim size. Your output argument, this size is argument is specified, and output argument tsxr string is also returned. Then the continuous and discrete states are updated using the corresponding subfunction MDL derivative and MDL update respectively. The updated state variables are returned in SYS argument. And in step 3rd, output signal evaluation, the function MDL output is called, and the output signal is returned in the argument SYS. This is implementation of S function. How we implement the same template that I described, no need. Template and file S function. The template consists of a top level function and a set of skeleton subfunction, each of which correspond to a particular value of function. The first function that you define through function definition line, function SYS, X0, STR, TS. This is top level function. And that you call in each corresponding to each value of flag, that is your subfunction. The top level function invokes the subfunction indicated by the flag. The subfunction, which are called S function callback method, perform the task required of the S function during simulation. Corresponding to each flag value, each subfunction perform task. It is recommended that the structure and naming convention of the template be followed when creating M-file S function. This makes it easier for others to understand and maintain M-file S function that you create. These are the templates which are available corresponding to level 1 M-file S function. Continuous time CS function. Go in your command window, type, edit this name. It will open the template, this one. Inherited sample time. Again, go in command window, type, edit this name. It will open inherited sample time template. Unit delay template. Again here, this times 2. Used to implement scalar level. This is level 1 MATLAB file S function template. This you type, edit S function TMPL in your command window. Edit This is your S function, level 1 S function template. General MATLAB S function template. With MATLAB S function, you can define your own ordinary differential equation, discrete system. I told you it is used to model dynamic system, ordinary differential equation, discrete system, or any other algorithm. A general form of M file S function is this is general form of S file function. This is the name of the file name of the S function. In case of a function is always saved with the same file name as the name of the function. This is description of flag. 6 flags: 0, 1, 2, 3, 4, reserved for future. This 5 and 9. Switch case statement. Initialize. MDL derivative, MDL update, and output, and then terminate. Sorry, get time of next variable hit, and this terminate. As functions example, if you go in your user defined library, and if you take this S function example block, and when you double click this S function example block, what we find, it contains MATLAB file S function, C file S function, C++ S function, Fortran S function structure. If we double click on MATLAB M file S function, it will open level 2 MATLAB file function and level 1 MATLAB file function. In case of level 1 M file S functions, it contains ×2 limited integrator, unit delay, inherited sample time, continuous time variable step, MATLAB file. Already available templates in level 1 M file S function 5, and this is your level 1 general template. If you double click on any template, it will open its template available. Now open Simulink, and in Simulink go in user defined library, and in user defined library, if you this S function example, S function example block, MATLAB file S function, C file S function, C++ S function, Fortran S function. MATLAB, if you double click on this MATLAB M file function, level 2 MATLAB file S function, level 1 MATLAB file S function. If we double click on level 1 M file S function, it open all the templates available. This, if you click on this is already existing model. Firstly, we take example of this ×2. It is simple. This ×2 template, what we are doing, we are multiplying a scalar by some value. If we double click on this S function block, it opens 3 field. In case of edit field named S function name, we enter the names of S function. S function's parameter in the edit box labeled S function parameter, we enter the optional parameter P1, P2 that we supply it to the. This is the name of times 2 function, and only flag 0 and 3 is used. Flag 1249 is set as empty, and here in case of MDL output function, here the output is multiplied by 2. When you close it and if you click on this C file as function, continuous, discrete, data type, multiplication, this is basic CMax template, and this is detailed CMax template. Basic CMax template. If you click it here, detailed CMax template. C++, Fortran, S function. So these are the various S functions available under S functions example block. Now I will take an example of times 2 block. This is modification of times 2 template to compute the step response of a first order system. The step response of first order system is basically it is given as 1 minus exponential minus t by tau. Tau is your time constant, which I assume it here 5. This is the modification of template. Name of the function is step basic RC. This template here used is number of continuous state is 0, discrete state is 0, output is 1, input is 1, there is a direct feed through, sample time is 1, X note, this is null, STR is reserved for future, TS is set 0, 0. This is your MDL derivative not used, set as empty. MDL update not used, set as empty. Then MDL output expression is written here for first. Close it. See, this is basically the step response that we computed using transfer function, and this is a time domain implementation. 1 minus this 1 minus e raised to power minus t by tau, and this is S function. S function, what we do? We firstly create modify the template whose name is step_basic_rc, and then we drag these blocks from user defined library into this model window. We double click on the block, and in the edit field name, S function name, we enter the name of the S function. The parameters are yeah, otherwise it give error. Folder in the same folder. Name. This establish a connection between your Simulink mod S function and your M file. Function M file. So this we close, and then I set this simulation time as 40 and run. So it is executed. This is step response using transfer function block, step response using this time domain, analytical time domain, and this is using all three. So S functions work. Now we try to provide the additional parameter. Instead of this time constant as fixed value, we provide it from the S function, this S function parameters. So
whenever we want to create a thing, I think we have to go to the template.
Yeah, you have to. It is always recommended to follow the structure and naming convention of the template. So in your command window, the name of the template you want to modify it, press enter key and put it into your work folder, and this work folder should be in your current. This is again the same. The only change is here, instead of 5, the time constant RC is given in your this part. Close it. This start. Now in your command window, firstly we have to provide this R and C.
Hello. Hello.
Ma'am, do you have any doubts?
Yes, ma'am, we are having any doubts.
Yeah, just you can ask.
Hello, ma'am. I'm Astha Vyas from JEET Jodhpur, JEET Institute of Engineering and Technology. My question to sir is that in convolutional encoding, when we are performing it in the Simulink, when we are deciding the soft decision decoding of that particular thing, how we are analyzing for the different transmission code rates, the data bits, like suppose for 1/2 code rate, 1/4, 2/3. So how we are deciding the soft decision bits for that in soft decision decoding?
In case of this, you have to just give your sample rate in your S function template coding, number of continuous.
Sir, it would be like helpful, like if you can show an example of two different rates, and can you show that like how we are deciding the bits, soft decision bits for that decoding?
I have no example for that.
Actually, say, sir, is giving you the basics. When we are doing some research or something, we know more about it, isn't it? So you can just try this. Now you just see that we understood that there are templates and you can go and modify your program and you can implement it. This is just a model key how to do it. Simple programs we are doing. When you want to go into depth and do it, you can just try it in your end. Hello, ma'am.
Hello.
Actually, say, sir is explaining you the basics. Okay.
Level 1.
So the level 1, and he is telling you about the different format in which you can implement it. So what I feel is, say, everyone have their own problems. Okay, so I don't think so any expert, if you ask them, it is very difficult for them to just tell it. So now it is our thing ki when you are inside a field, you know that very clearly, you have to think about it, how to implement it using that.
Okay,
Okay,
thank
so
you.
so when I'm also thinking, like I'm just thinking of my problem, how to implement it. So this is a basic thing. So sir is telling you the format and the template and the process how to implement it. So we have to just think on ki what is our problem and how will we fit our problem into it.
Okay, thank you. Thank you, ma'am.
So this is again the same problem. Here, the additional parameter A, R, and C is supplied through the edit box named as function parameter dialog box. And in case of your template, these three variables. ये पहले केस में नहीं डिफाइन की थी. सेकंड केस में हाँ मेंशन किया है. पहले देने थ्रू डायलॉग बॉक्स as function dialog box. If we click on this as function dialog box, the two fields are important. As function name, specify the name of the as function, and if you have any additional parameter that you want to specify, provide it through this dialog box. A, R, and C. So
from where will we give the value now?
Now from the command window.
Okay.
From the command window. From the command window, and it this A, C. So specify A, R, and C. Suppose A we specify A equal to 10. So now we go in your yes, already specified. So it is executed. Now if you look this is so in this case the as functions additional parameters are supplied through the dialog box. No, the programming template, yes, it is a specified template. Yes, templates are available for, I told you, suppose you have a system with no continuous state. So you go in times 2 template. Times 2 template means just you modify your own things. And if you find there is a system, I will take an example of this is basically an example of a first order system. So first order system can be modeled using transfer function or state space approach. And if it is an example of a continuous system, go in continuous system function template simply. There is no need to write your own template when it is existing. The only thing is you have to modify the template as per your requirement, as per your functionality. And if you find there is a discrete system, so you modify the discrete system template. That is this is a structure of a M file template that I already explained. Structure of M file. Deconstruction of if you look at the times 2 template, the first line is your function definition line. After the first line, the S function file is split into different case determined by the flag. There are 6 flag values, so a switch case statement is used. And in case of this times 2 template, only 0 and 3 is used, so 1, 2, 4, and 9 is set as empty string. The last 2 lines of, you can take this as a times 3 template also to catch exceptional case when there is a error has occurred during simulation. For case 0, initialization, the function MDL initialize size invokes the sim size command. Firstly, the sim size command is used without argument. Sim size, it creates a structure variable. Then we specify the parameter. Then again using the command sim size, again we create a structure variable as the argument which actually translate the value in the structure size into a raw vector. It then initializes the states, state ordering string, and sample time. For case 3, you can take 3 here. Steps in S function simulation. Insertion of S functions into Simulink model. How we use this S function? Firstly, open your untitled model window, copy your level 1 M file S function block into it, double click on the S function block. In the S function block's name field, edit or enter the name of the S function file, and then a connection is established between them. Specify the input and output, run your model. I just take other example of level 1 M file. This is again the same problem. Name of the S function here we specified in this block, and if you look at this S function, this function definition line, function name, here it is a continuous system, so we use this derivative, and a function in this is called here this. This function R and C is specified here, this. So this is your step signal of, and this is your step response. This is one of the example that is taken from a famous book, Mastering Simulink. Here again times 2 template is used, and there are 2 input signal, and is this first input signal, second scale. This is computed. So the name of this S function is input argument, output argument, this switch case statement, then first function MDL derivative empty, no continuous state, no discrete state, this MDL update, this is only set. Let us to create this model, we firstly drag this S function block. In template, we write specify the name of the S function. Then we give 2 input signal through this, and we visualize output here. Run the simulation. You can change constant 1 input, step 10 final value. So 10 square plus 1. This continuous state template is used to create this M file S function. Matrix A B, C, D is specified. The flag 013 is used, and the 249 is set as empty string. This function sys in this initialized size is called number of continuous state 1, number of discrete state 0, number of output 1, number of input 1, direct feed through, and through. The meaning of this thing is, if you have a state system, state variable should be explicitly specified in terms of output. X derivative equal to ax plus b, y equal to cx plus d. So there should be direct state should be clearly specified. Or in case of a no continuous state, the output should be an algebraic function of input, like y equal to ft. So it should be that.
It's not specified before 0.
0, yes. This in case of continuous system, we use this update of continuous state. So this is this, and the output is computed here. This tail out. This, when you run it, this is state space block, transfer function block. This is your S function blocks. So this is implementation of S function, continuous system S function. Let us take an example of second order system. Again, we take this continuous system template. The matrix A, B, C, D is specified here. It can be entered through the dialog box also. So A, B, C, D flag is used as 0, 1, 3, and 249 is set as empty string. The first function is invoked. First function MDL initialize size is called. The first command is used to create structure variable. The 6 essential members of the templates are called number of continuous state 2, discrete state 0, number of output 1, number of input 1, direct feed through 1, number of sample time 1, continuous state and discretes. This is your transfer function block, CS function block. So and so all these are the example of level 1 M file S function block. Level 2 M file S function block. Again, in case of level 2 M file S function block, different templates are available. The first 5 template of level 1 are already existing here. Times 2, unit delay, continuous, limited integrator, inherited sample time, and this. So level 2 M file S functions are continuous time, variable step, MATLAB M file, inherited sample time, limited int. These all are the templates of level 2 M file S function. And there is 2 more template, basic template and general template. This is your level 2 M file. First 5 models of level 2 M file as functions are same as those of level 1 M file as function. In case of first problem, we take the step response of first order system. The same can be implemented using level 2 M file as functions template, basic times 2 template. If we double click on level 2 M file as function template block, it displays the structure of level 2 M file as function template. To create a level 2 M file as function, we simply copy the template that Simulink provide and edit the copy as necessary to reflect the desired behavior of the S functions you are creating. Means you copy the template and edit it. Level 2 M file as function consists of a setback of callback method that Simulink invokes when updating or simulating the model. Level 2 M file as function blocks contains more functionality than the level 1 M file as function block. The callback method performs the actual work of initializing and computing the output of the block defined by the S function block. How to write S function block that I told you? Firstly, write the S function block in MATLAB editor window using M file. Save the function exactly as the name in the MATLAB work directory. Open Simulink and open a new model window. Click the user-defined function of Simulink library browser. Drag the S function block to new model window and click on the block to change its name exactly as function name declared in M file. Then this block will work as the user-defined block, which will behave as the other existing block in Simulink library. General structure of Simulink block. Conclusion of this. The power of the S functions in creation of customized block for a specific application has been presented. You can create your own custom Simulink blocks. It depends on the user, which kinds of functionality you want to implement in level 1 or level 2. Two different approach, level 1 and level 2 are taken here. Systems with any complexity can be modeled using S function block. Dynamic system, modeled with continuous state, discrete state, hybrid system. M function method cannot accept additional parameter which limit the use of the S function, which limit the use of M function, not S function. Sorry, it is basically, if you look at M function, whatever the input arguments you supply in your function file, can you provide more than this input argument? No. Here, in case of S functions, you can provide additional argument using the dialog box of the S function block. So that is all about level 1 M file S function block. Now, after it, we come to level 2. S function builder block. This is your S function builder block. If you find there is a user which is not having C programming expertise and want to use this level 2 M file S function block, then it is recommended to use this S function builder block. In case of S function builder block, the first thing is you copy this S function builder block from user defined library, and in the name, S function name field here, you enter the name of the S function that you want to create. Suppose we give it S, simply I write a simple example, sum. Then this S function builder blocks have these different pane initialization, data properties, libraries, output, continuous, derivative, discrete, building information. If you look at your problem, it can have only no state, continuous state, discrete state. So simply if we take to add two number, then what we define, we come to this data property pane, and in case of data property pane, it is used to initialize ports and parameters of your S function block, and here we enter input variable, suppose A, then add second variable B, go in output, here suppose C, then go this on this build information pane, build, click on this Alright, yes. Let's start. Yes, three different files have created. The first file is S underscore sum. This is the name of the S function that I specified in the dialog box, followed with .c. It is used to create C code of your S sum, generated a wrapper.c and TLC file. You click here on this. This is your generated code. Yes, code. It generate code. No, go here. You in this part specify star C equal to star A plus star B followed by semicolon. Save it. Go in your copy this S function builder block. And these three files are here. This is wrapper.c in your current directory. This .tlc, which is for running your this model in accelerator mode, and the model is S function name is
सर वैसे मेरा नाम सर अनिल सर उनके बाद
go in max already exists. Yes, yes. It means that is probably inbuilt compiler LCC or that problem. Next setup. इसमें नहीं problem. There is a problem of compiler. I can show it on other laptop that is with yes. Max executable file is not created. So this is the problem.
Which compiler we have to install?
It is already inbuilt LCC compiler. I can show it on other system if you say. Earlier I have also executed this model but not able to run.
This is the procedure that
Yes, yes.
first go there and take the function,
yes.
then enter the name, and after that
Yeah, and in case of a continuous system, in case of a continuous system, this continuous derivative in or libraries. So if you want to include any external library, so this.
Is there help available for this S function also in demos?
Yes. So this is all taken from the help. The firstly you specify the name of the S function in S function name field, then specify input and output port parameters in data property pane. Initialization is basically if we have a system with continuous and discrete states, so then we specify this, and the number of continuous state or discrete state is equal to the in number of initial condition is equal to number of continuous state. Data property pane, you can add input port or delete number of input and output, or you can shift it up and down. Then input port you specify here, output port parameters you specify, and then libraries output. Just simply build your block continuous, and then it creates 3 files, your S function dot C file, wrapper dot C, and TLC. In go in wrapper dot C file, you add your your functionality, and then go in your MATLAB command window.
When we change that, after that should we save that in some location?
It should be in the current directory.
Okay, it should be in the current directory.
If it is not in the current directory, it will give an error always. Then you run it.
Once you build it, it will go in the current directory and it will be built there. So
Yeah, it is built there. Then you have to go in your command window, MATLAB command window. Then you have to write max के बाद पहले .c file, and then you have to write .wrapper as function, then it will run.
then how will we bring it to simulate?
This S function is created. S function builder block is used itself in the simulate. This S function builder block is used as that in a this is S function builder. Just like your level 1 M file S function, it is used. S function builder block is used. In place of this, you can use level 2 M file S function, S function builder block, or we can use this C function builder block. So there are number of templates for level 2. This S function example blocks contains only example. S functions builder is for max, and S function block simply is for level 1, and level 2 is this. You take this block. If we click on this S function 2, this is the template of level 2 MATLAB S function. This is your primary function times 2 MSFC and times 2 block. It call a function setup block. This function has only one input argument block, and it returns no output argument. Within this function setup block, we initialize the basic attributes of your S function block. Here we specify number of input and output port. So this level 2 M function block is based on object oriented methodology. We specify number of input port 1, number of output port 1. This to set functional port properties to dynamically inherited. we specify block sample time. Block dot sample time. We specify this. We call this block dot register block method. Only one. A level 2M file function must include at least two callback method. One is your setup function and other is your output function. If you look at level 1 function, we call initialize and output. Here the first function, this is setup block. It is used setup block, setup, and then this is 2 times. This is output. Here block output port 1 dot data. This is 2 times block input port 1 dot data. Let us save this template on the desktop times 2 desktop. Save it. Specify the name of we saved it on desktop and the name is yes. And if we want to write it for this is a step response for first order system using level 2 level 2s function. If we look at level 2s function, this is structure. Primary function, name of the level 2s function, setup block. It calls a function setup. Within this setup function, you have to define the basic attributes of your block. How many input it port, number of input and output port, sample time of the blocks, block direct feed through, dialog parameters, and this. Yeah, this. And in the function output block, here 1 into this. This is written as this way. You're right. In case of this level 2M file as function block, this continuous time variable template. If we look at this template, in fact we look at general purpose template rather than level 2 M file. This is your general template for level 2 M file as function. The MATLAB S function is written as a MATLAB function with the same name as the S function. Replace the name of the template with the name of your S function you want to create. Start with this level 2M file basic template. This is annotated template. It should be noted that the MATLAB S function is very similar to level 2C max S function. The first thing within this S function is your function setup, and it set the S function's block basic attributes or characteristics: number of input ports, number of output ports, dialog parameters, option. Look at level 1 M file S function initialize function. What we do there? We specify 6 essential templates, 6 essential members of the template: number of continuous state, number of output, number of input, sample time, and so this is more having more functionality. Register the number of port, block dot number of input port 1, number of output port 1. Set the port properties to be inherited or dynamic. It sets the sample time according to your input signal. Then specify the attributes of this your input port. Block dot input port data type 00. Complexity real or complex. Block input port 1 data type complex. Override the output port property. Similar block output port properties. Block output port 2 dot data type this. Register the number of parameters, the parameters that you want to enter in the S function dialog box 3. Number of continuous state. A number of discrete states are not initialized in setup block. Number of continuous states are initialized here. Sample time blocks. This you have to see. This sample time is a combination of two things. The 0 and offset is 0. Continuous sample time is 0. Discrete sample time offset positive number. Inherited sample time always -1, and variable sample time -2. This sample time is for continuous sample time 0. Option, then specify the accelerator that used with PLC, sim state compliance, and block dot register block method. At the end of this function setup block, we call register block method. This block dot register block method for set input port sample mode. There are 2 input arguments. This is one, this is other. This is function handle, and block register block method set all this set output port data type, set input port complex signal type, register block method. So the and process parameter, initialize condition, start, and when at the end of this we have a block dot register. Yes. This is end function setup. Function, primary function, setup, call function setup, specify the basic attributes of the parameter. If you look at level 1, it is very small. Level 2, there is more functionality. Then these functions you have to call here corresponding to check parameter, process parameter, input port dialog box, sample. So Dwork is basically it is used to store discrete states of the vector. It is a discrete state vector used to store discrete function initialize condition block. So this is the template of a level 2 general template. You can look on this any template. Inherited sample time, if you look at inherited sample time template, inherited sample time is C -1 0 block sample time. Block sample time is -1 0. Name of S function block, setup, function setup, number of input port, number of output port, and this block sample time. This. So there are a lot of level 2 S function template that you can use depending on your choice. So any queries, please?
Nodal centers, do you have any queries? So anyway, okay. If anyone have any query, you can switch on your mics. So thank you, sir. It was really a very interesting lecture, because now you now those who are in the initial stage, you will not know it. But when we are doing research and things, in first lecture also I showed you a windmill. So that was an animation where the programming was done along with the animation. So when you want to bring animations and all, you cannot do it like in MATLAB directly. You will be using some other say C or some other language you will be using. So those programs, if you want to bring it here into Simulink, you have to know this S function. So this is a very important thing. So those who are working on it, now anyway you understood the concept. Because before I have also worked with S function, I simply used to put the block and write something, that's all. But now we understood there is a template and this is how we have to write and this is how we have to program. So we can start with a simple program and you can try it. So you'll understand the concept. Or sometimes when you're taking some animations and you're putting also, you can just go and see what type of template they used and what they have programmed. Now you know that how to look into a program which is already existing. So first of all, first step what you can do is you just go and see the programs which are already existing. Just try to analyze it. Then you will understand the concept and then you can try to implement your problem into that. Okay, so this was really a very useful lecture, and I thank sir for coming such a long distance and delivering a wonderful lecture. And thank you once again to everyone. Tomorrow, sharp 10 o'clock, we'll start with the optimization lecture. Okay, thank you, sir. Thank you.